Yes, good evening everyone. Right. We have discussed PMMC instrument, construction and operation we have taken. What is the formula of deflecting tile? TD is equal to BIN into A, right? And theta equal to what we have got? BIN into A by KC. This is the formula we have taken. Right? Now, the point here is, sir, this is in terms of radians in general, right? Now, after that we have taken, sir, N is constant, A is constant, Kc and B also constant, theta is proportional to current I we have taken, and we have proved that this is linear scale or uniform scale we have taken, right? Now, and last one, sensitivity also you have taken. Sensitivity S is equal to, what is the formula? BIN into A by Kc, that is theta formula. Thereby sensitivity equal to change in output by change in input. What is that? BNA by Kc, right? What is that? Kc constant, A constant, N is also constant. Of course, B is also constant, but nature I'm taking. Therefore, sensitivity is proportional to flux density. As the flux density is stronger, sensitivity is also high. That's why PMMC instrument advantage is, which one here? High sensitivity you are taking. This is the simple topic we have taken in yesterday's class, and numerical questions also we have taken, right? Now, and one question I guess as the homework question. What is that? 5 amperes, 90 degrees. 3 amperes, how much? What I gave you? TD proportional to I. TD proportional to I, right? So based on this, what is that? Theta 2 by theta 1 is equal to I2 by I1. This is spring control method. And gravity control method. What is that? Sine theta 2 by sine theta 1 is equal to I2 by I1. Right? Now, theta 2 is equal to theta 1 is 90, I2 is 3, and this is 5. Right? What is the answer? No need to wait for the answer. Already clearly it is indicated. No, don't worry. That is the answer. Right? How much? 54 degrees. Few people are giving 48. No, yeah. 518s and 90, not 516s. So 54. And here theta 2 is equal to, you will be getting 36.86 degrees. These are the answers for yesterday's question. Clear? Right. So what you have got, now I'm starting the topic. What we have got here? Theta proportional to I we have got. Finally. So already we have proved that PMMC instrument reads average value or RMS value. Average only. Therefore, from this what we can write, therefore, theta proportional to I, but which current? I average only. If I write like this, this is simply, what is that? Ammeter. And if you want to write the altimeter equation, What is it? Theta proportional to I average. I average also proportional to V average. Why? The supply current depends on supply voltage, Ohm's law base. So therefore, this is the voltmeter. That's why PMMC instrument can be used as an ammeter and as a voltmeter. Suppose if the device is designed with, which one? Low internal resistance. That is called as ammeter. The manufacturer give that as a letter A. So simply, yeah, that is which one? Ammeter. Suppose voltmeter, if you want to design, manufacturer should keep high resistance as the internal element. So therefore, this will be given as V letter. This will be given as A letter on the device. So therefore, we can say corresponding PMMC can be operated as, can be designed as an ammeter and as well as voltmeter. Clear? Right. Now, sir, suppose we are having one PMMC instrument. Right now. If the PMMC instrument has some capacity, but we want to measure some extra, some more value, means suppose I have 0 to 1 ampere PMMC. I have 0 to 1 ampere PMMC. Suppose I have only 0 to 1 ampere PMMC. Okay. So in the circuit requirement, right? Here in the circuit requirement, we have 10 ampere requirement, 10 ampere measurement. Is it possible to measure 10 ampere circuit with the 1 ampere directly? If I give directly, what happens, sir? The instrument gets damaged. So that is the reason why what we are going to take here is, that is extension of range. Extension of range of PMMC instrument. Extension of range of PMMC instrument. Sir, what do you mean by extension? That I'm taking now. Concentrate. Right? What is the meaning of extension? Kindly concentrate. Here, PMMC can be operated as ammeter as well as voltmeter. So first one I'm taking as an ammeter. As an ammeter, right? Means I want to extend the range of PMMC ammeter. Okay, as an ammeter, we're extending, means current measuring circuit we are taking and we're extending the range. But when, what is the necessity and how, everything I'll explain. Suppose we are having one device like this. This is PMMC device. But sir, PMMC complete construction we have taken. No, sir, every time we need to take that entire construction, it is very difficult. That's why PMMC equivalent circuit. So what is equivalent circuit? I'm drawing here. Equivalent circuit. Concentrate here. PMMC equivalent circuit is drawn as, concentrate here. This is PMMC circuit or PMMC instrument. Pointer, spindle, springs, bearings, everything is in this only. And PMMC instrument has one coil, current carrying coil we can say. So therefore, that coil I'm showing outside. So generally, coil means R or RL combination, means coil means always RL combination. So therefore, R and L. But PMMC is only for DC applications generally. That is the reason why inductance need not to show. Why? Under DC condition, steady state condition, DC, inductance acts as the short circuit. That's why symbolically only with resistance, that is meter resistance, we will show like this. This entire box is PMMC device. What is it? Actually, coil means RL combination we have to take. But sir, the inductance acts as short circuit for DC under steady state conditions. So that's why be careful. I'm not showing the inductance. This is what equivalent circuit representation of PMMC. Okay, right, sir. This is generally I follow, but in the textbooks notation, like this. This is RM. Like this, they will indicate Rm in the circuit itself. Both are one and only same. But for clarity purpose, I am showing Rm outside. They are taking Rm inside the structure. Both are one and only same. Okay. From now onwards, if I indicate only resistance, it implies PMMC device, right? How do we indicate Mi and all? We'll be seeing that later, one by one, we'll be seeing that. Okay, right. Sir, here, suppose I'm taking the PMMC instrument like this. This is Rm. This is Rm. Like this. Okay, right. Now the question here is, assume that, kindly concentrate, concept is very, very important. Mathematics is very simple here. Sir, we are having 0 to 1 ampere PMMC, for example, which is there, 0 to 1 ampere PMMC is there. But the circuit point of view, suppose 0 to 10 ampere current is there, right? Other device is not there. With this device, can we study these higher currents or not? With this device, can we study these higher currents or not? Yes. How? How means concentrate. So I am joining this like this. But the moment I join like this, instrument get damaged automatically. Why? It has the capability up to 1 ampere only. But now it is having up to which one here? This one 0 to 10 ampere one. Okay. So therefore, what is the point here? Suppose if I make one path like this, what does it mean? This current is coming over here. At this point, it is divided into two parts. Therefore, yes, the corresponding PMMC device may be operated under safe conditions. Okay, happy. Right. This current I'm taking as IM means meter current. This current I'm taking as ISH, shunt field current. Okay. As it is PMMC, yes, definitely we add resistance in the parallel RSH. Clear? Right. Sir, I'm adding like this. After that, now tell me, do we have any chance of saving the corresponding PMMC instrument, or to have the safe operation with PMMC instrument? Yes or no? Yes, chance is there. When RSH carries large current, then IM will be small, thereby the device will be operated under safe conditions. That's why what should be the condition here? Very, very, very important condition is RSH is far, far less than RSH is far, far less than RM. So what does it mean? If RSH value chosen by us is very, 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 very less than RM value, then this ISH will be very, very, very larger. IM will be very, very, very smaller. Then automatically device will be operated under safe conditions. So this is what the first criteria to correspond to go for the extension of range. That's why, how do we extend the range of PMMC ammeter? Means by connecting a shunt resistance, by connecting resistance in parallel with the meter. If you are connecting resistance parallel with the meter, yes, we can save the corresponding structure. Okay, but sir, how much is this value? That is what we require. That is only extension of range of PMMC. Means how do we know that, or what is the value of RSS? Simple mathematics, sir. Here VSH is equal to VM. VSH is equal to VM. Sir, why? Shunt resistance and this resistance both are in parallel. Voltage across this, voltage across this, both will be same. So VSH is equal to VM. So what is VSH? VSH is equal to current into this ISH, RSH, VM, IM, RA. Okay, right, sir. Here, what is ISH? This is unknown large current. I'm taking as I. So therefore, ISH I'm writing as I minus IM into RSH is equal to IM into RF. Okay, therefore we can find out the value of RSH. RSH is equal to Im into Rm by I minus Im. Clear? Now what we can write here? I'm bringing Im to the downside. So Rm I by Im minus 1. This is the formula of which value? RSH value. Clear? So what is the formula of RSH means? Yes, Rem by, what is it? I by Im minus 1. Clear? Right. The question here is, this entire concept is regarding when we don't have the 0 to 10 ampere ammeter with us at that moment. 0 to 1 ampere can be extended to study 0 to 10 ampere, 20, 30, 40, etc. That's why with the available device, how do we extend? With the available device, how do we extend the range? How do we extend the measuring capability? That is what the topic here. Right? Okay, sir. After this, I'm extending this. Let I by Im is equal to M. That is multiplying factor, or we can say multiplying power. This is multiplying factor, multiplying power required in this. So therefore, what we can get, RSH is equal to Rn by M minus 1. Means if this is the value, if you're placing here, automatically we can have the save operation, no problem. Okay, one thing. Second thing, sir, our mathematical formula is correct or wrong? Our mathematical formula is correct or wrong? Right? The point here is concentrate, sir. This is I 10, just maximum current I'm writing 10. What is the maximum current IM? 0 to 1 only, 1. So 10 by 1, 10 by 1, 10 minus 1, 9. So therefore, RSH is equal to 1 by 9 times of RM. RSH is far less than RM. RSH is 1 by 9 times of RM. Satisfied? So therefore, our mathematical formula is correct. But here, very common doubt for with everyone. Sir, 0 to 10 ampere is there. Suppose if I give less than 1 ampere. First of all, if you have less than 1 ampere, why do you go for extension? Are you getting? See here, if you are having less than 1 ampere, whatever the device is available with us directly means this is not required. Generally 0 to 1, let it be given like this. That's why our topic is whenever the available value is more than the instrument capacity, but for writing purpose 0 to 10 only we write. Don't write 1 to 10, etc. One writing purpose, conceptual purpose, 0 to 10 only we write, but 0 to 0.5 range or 0 to 1 range is there. Do we need to go for extension? No, yeah. Our device is operating properly. That's why be clear. For writing purpose, we write like this only. But strictly speaking, whenever the unknown value is more than the instrument full scale value, then we go for right, then we go for corresponding engineer extension method. Otherwise, we don't prefer at all. The two proof also gave you RSH must be far less than RM. Yes, RM by 9 times in this question. Suppose people are asking, sir, why only 10? You can take 20 also, no problem. What you have to keep now? Here 20, instrument capacity 1, 20 by 1, 20 minus 1, 19. RSH is equal to RM by 19. Suppose if RM is equal to 1 ohm, you have to take this value as 1 by 19. By designing the entire circuit. That is the reason why. Be clear. Our intention is not to disturb the device. Our intention is to measure the larger values with the small capacitor device. But be clear, with the addition of this element, the instrument construction, operation, or its own full scale value, anything is there should not be disturbed. That's why this element is not connected in the circuit. This element is connected externally. That's why this dotted box is PMMC. externally we are connecting, that is RSH. Clear? So that is the reason why, without disturbing the corresponding instrument, so we need to know corresponding, what is that? RSH must be connected. One thing. Second thing, PMMC instrument. People are asking, how does the PMMC know that more than one is there? Operator knows. Then disconnect this 0 to 1. Don't use this. Suppose it is having 0 to 5, 5 to 6, different ranges are there. Connect this one. Instrument will not think, but operator is there. We will be there. We can think. So that's why we are going to connect the corresponding structure. Clear? Right? Right. See, in this case, RM is large. No, yeah, RSH is far less than RM. Don't say RM should be very large than RSH. No, RM is 0.1 ohm. RSH is very less than 0.1 ohm. That is what the topic here. That's why RSH must be chosen as very less than the corresponding RM value. That's what the actual point. Clear? Right. After that, sir, PMMC, very important point. PMMC will not show this larger current. PMMC will not show this larger current. What does a PMMC do? That I'm giving now. Concentrate. Topic is not completed. RSH is equal to RM by I by IM minus 1. Okay. I'm bringing here I by IM is equal to what we can write, RM by RSH plus 1. So therefore, what is that? I is equal to IM into RM by RSH plus 1. Concentrate. Sir, after designing this RSH value, assume that this is 1 is there, this is 1 by 9, we kept it. Okay. The element is designed. Okay. Be clear. Now, sir, this current is unknown. So 5.5, 6.5, 7.3, we don't know. Some up to 10 is there. Unknown value is placed. Be clear? So far, what you have done? We have calculated the value of RSH and kept over here. Okay. Sir, I'm giving some 5 to 6 amperes range. 5 to 6 is known, but 5 is there, 5.1, 5.25, 5.3. We don't know. That's why some current is given. Right? Now, sir, the moment we are giving this current, be clear, this current is coming up to this. At this point, the current will be divided based on the available resistance through this large current, through this smaller current. Obviously, what is it? Less than 1 only. Less than 1 only will be there. Okay. Sir, if it is less than 1, assume that. Concentrate here. Very important point here. Some X amperes is given. Okay. Some current is flowing. What will be the current? Can it carry more than 1 ampere? No. Up to 1 ampere only we kept here. That's why the current will be. Assume that the PMMC instrument reads, when X is given, PMMC instrument reads some 0.65. We don't know something. Okay. Sir, here 0.65. Right? Substitute mathematically. RM value 1. RSH value 1 by 9 plus 1. What is that? 0.65 into 1 by 9 means 9 plus 1, 10. So automatically 6.5. Right? Now tell me, 6.5 is more than 0 to 1 or not? Yes, 6.5 is more than the instrument full scale value. Are you able to obtain or not? Yes, we are able to obtain. But very good question here. PMMC instrument shows the value? No. PMMC instrument shows up to 1 only. But with the mathematical formula, we are able to study larger value of current. This is what the complete picture regarding PMMC instrument, that PMMC ammeter extension of current, extension of range. Clear? Now, I'm giving the complete summary here. If this is clear, PMMC voltmeter will be same concept. What is it? I'm coming again. We are having 0 to 1 ampere device only right now. But we are in need of measurement of 0 to 10 ampere current. Okay, right, sir. It measures up to 1 only, but our requirement is to study up to 10 amperes, up to 10 ampere. Therefore, yes, current division should take place. What is that? Parallel branch is connected. One thing. Through this path, 0 to 1 means maximum 1 only. But up to which current we are measuring? 10. So therefore, this RSH should carry more and more and more current. Therefore, RSH must be far, far less than RM. One condition. Mathematical formula we have taken. Okay. After calculating this RSH, keep it over here. Some Y over something. Okay. Right. Now, we need to give unknown current 5.6, 7.5, 6.5, any number below 10. You give it. We don't know, but give it. And range is known, but value is not known. That current is coming over here. At this point, getting divided. Yes or no? How it is divided? Based on this resistance, and based on this resistance, current will be divided. Yes or no? So therefore, based on the current flowing to the PMMC meter, it will show some value. It may be 0.675, 0.65, 0.56, 0.35, any number, but below 1 only. In that will be designed. After measurement of value below 1 with the PMMC, substitute in the formula. RM is already known. RSH we have calculated. Simply you are getting the corresponding larger value. But no doubt, sir, we are not measuring now. It is not the measurement of larger current. It is the study of larger currents. Possible or not? Yes, possible. Yes, possible. That's what the point. Clear? Right? Okay. Now, here, sir, suppose if 10 amperes is given, if 10 amperes is given, what will flow? I'm giving as a known value. If 10 amperes is given at this point, divided, it will show how much value? 1 by 10 is the maximum. Definitely will show 1 maximum. Substitute that value. Here 1 by 9 plus 1. So 9 plus 1 into 1. So simply 10 ampere. Yes, got it. 10 ampere. In that way, the current can be measured. Large current can be observed, or large current can be obtained mathematically. This is the complete extension of range process. Clear? Right. Very, 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 very important point is here. We are not changing the scale. Almost 100 people out of 100 are having the doubt generally. See, sir, after extension, what about the scale? That's why just now I told you, are we disturbing the instrument scale? We are not disturbing the instrument scale here. We are the operators. How can we change the instruments? That's why instrument full scale value is still 0 to 1 only. Externally connected. Just I told you, this entire element is externally connected. We are not disturbing. That's why the RSH connection should not disturb the instrument construction, instrument operation, instrument full scale value. Everything will be as it is, only it should not disturb it. And that's why I told you clearly, this is connected. After connection of this, kindly don't say, sir, make it 0 to 10 now. Come on, how can you say that? It is still 0 to 1 only. That's why I told you, PMMC instrument still reads up to 1 only. Still reads up to 1 only. Clear? Right? So, while designing RSH, how do you design means, what is your requirement? Based on the requirement, you have to take, all I told you, this is 10, this is 1, this is something. So therefore, RM by 9 times. Suppose if it is 100, for example, 100 by 1, RM by 99. In that way, we need to design the corresponding RSH value. So this is the total discussion regarding PMMC ammeter extension. PMMC ammeter extension. Clear? Right. Sir, scale is not changed. Scale is not changed means resolution is also not changed. You are missing small thing. This is not internal change. This is external change. This is external change. Okay. Now, coming to the second point. What is it? As a voltmeter. As a voltmeter. Now, total concept I'm revising again. Right? Right. If any doubt is there, yes, it will be clarified now. Clear, guys? Right. Sir, here, voltmeter. This is REM. Okay. And this device, this is 0 to 2 ampere. 0 to 2 ampere, right? Okay. Sir, sorry, voltage 0 to 2 volt, let us take. It is a voltmeter. But we are having 0 to 10 volt. Actually, more than 2 only it implies, but writing per we write like that. 0 to 10 volt, for example. Or you can take 20, or you can take 30, 40, 55, 65, 67, 87. That depends on your circuit requirement. That depends on your circuit requirement. Okay, right. Very good. Very good. Pranjali, correct. What is that? Now, in order to study this larger value, which must be chosen practically? Series branch or parallel branch? Series branch only. Therefore, yes, series branch. Okay. After that, the path will be closed over here. Okay, right. Same concept here also. Same concept, kindly concentrate. What is it? Sir, this is RSE, series resistance. Okay. Voltage across the meter is VM. Voltage across the series element is VSC. Total unknown voltage, supply voltage is V. Clear? Right, sir. 20 volts is given here. Sir, how much voltage must be dropped across this voltmeter? How much voltage must be dropped across this voltmeter means maximum of 2 by 2 is a drop. More than 2, it cannot be. If more than 2 is occurred, what is that? Instrument gets damaged. That is the reason why across RSC or across REM, across which element, more voltage should be dropped means RSC. So therefore, what should be the condition now? RSC must be designed as, what is it? Very higher than RM value. RSC must be designed as very higher than RM value. Clear? First condition. After that, very simple, sir. As these two are in series, automatically, what is it? The current will be same. Okay. Current through the meter, current through the series element, both are same. Sir, what is IM? IM is VM by RM. IM is VM by RM. ISC is VSE by RSC. Right? So, what is VSC? We can write voltage division law. V minus VM is equal to VSC. V minus VM is equal to VSC. V minus VM is equal to VSC. Okay, right. Now, in this, one second. V minus VM, sorry, by RSC. Okay, right. Now I'm bringing RSC this side. RSC is equal to, what we can write now? REM into V minus VM by VM. Okay, right. Sir, REM into V by VM minus 1. This is RSC formula. Now, our complete connection circuit is clear or not? Clear or not? Let us check now. Sir, what is V in our case? 20. 20. What is VM? 2. For example, I'm taking 2. So 20 by 2, 10. 10 minus 1, 9. 9 times of RM. So that RSC must be far greater than RM. Not by 1 to R. Multiplied by 9 times. Multiplied by 20, 30, 40. That depends on the requirement. In this case, yes, multiplied by 9 times means RSC must be more than RM. That don't say kindly REM must be far less than RSC. No, REM is already there. REM is our reference. REM is our reference. That's why RSC should be placed by us such that it must be, what is it? Very lesser than the REM value. One thing. Second thing, sir, are you disturbing its internal construction? No. Are you disturbing its internal scale? No. Are you disturbing its resolution? No. So that's why whatever the extension element we are adding, this element should not disturb the corresponding instrument at all. That is the reason why we are designing or we are connecting this from external side only. We are placing this external only, not internally. One thing. Same discussion again. Sir, let V by Vm is equal to some m. What I told you, multiplying factor or multiplying power, we can say. Power means not electrical power, multiplying value, we say that as power. Okay, after that, therefore, what we can write? Sir, RESC is equal to REM into V by Vm. I'm writing as m minus 1. This is the thing. Okay. After that, again, people are getting general doubt. This is general doubt. Sir, are we observing from the device? No, we are obtaining mathematically, but with the help of RSC only. Why? This much of RSC connected over here. Suppose this is 2 ohm. This is 2 ohm. 2 into 9, 18 ohm we are placing. Okay. After placing of 18 ohm, we can say confidently, yes, we can measure up to 20 volt safely without any damage. This 2 is already given with the corresponding mathematical discussion. 9 times should be there in this question. So therefore, 18 ohm is placed over here. After placing that, you can keep X voltage, Y voltage, Z voltage, ABC, any voltage below 20. Below 20, you can. So same discussion also here also, same discussion. What is that here? Sir, RSE is equal to REM into V by Vm minus 1. Is that no? Right. Sir, from this, V by Vm is equal to RSE by Rm plus 1. So therefore, V is equal to Vm into RSE by Rm plus 1. Right. Again, same explanation giving. Sir, here, suppose X volt is given, something we don't know. It may be 15.5, 16.5, 17.5, 17.2, any number, we don't know. Something. The moment we are giving the voltage, across this voltmeter drop will be there, but the drop will be maximum of 2, not more than 2. Why? This resistance is designed like that. Assume that this voltmeter is reading, suppose 1.75 for example. So therefore, here 1.75 into what is RSC? What is RSC? 20 by Rm 2 for example. And what is that? Plus 1. Clear? Here, what is that? 20 by 2. RSC is how much here? Here, this is 2. Sorry, this is 18. Some number, no problem. 18 by 2, 9. 9 plus 1, 10. 10 into 1.75. What is that? 17.5. Sir, the connected voltage is, the applied voltage is 17.5. But be clear, obviously, the topic itself is that people are getting one small doubt, general doubt. Sir, we are not measuring. No, I did not say from the instrument we are observing. No, what I told, whatever the instrument is available with us, that range is extended without disturbing its internal construction, internal operation, internal scale, and its own resolution. Everything will be safe, not disturbed. From external side, we are connecting. External side, we are connecting. One thing. Second thing, people are asking here, sir, anyway, we are using this formula, right? Why are you connecting this? Means, come on here, where we have to connect? Conceptually, you should know. They will asking that RSH must be, or extension of range of ammeter will be done by adding the resistance in parallel or series with the meter, means parallel. Conceptual question. Extension of range of voltmeter is done with adding the resistance series or parallel with the meter, means series. After that, use the formula and get it. Use the formula and get it. This is the total discussion regarding extension of range of PMMC instrument as an ammeter, as a voltmeter, as an ammeter, as a voltmeter. Right? Clear, guys? Right. Final conclusion point I'm giving. Final conclusion point I'm giving. What is it? You know, sir, while you are designing, what is known up to this much range is known. So this is unknown. While you're designing, this is already there. Means by this entire concept, you need to design the value of RSC. Okay. After designing the RSC, you are keeping here, this is 18, this is 2 something, kept it. After that, in the measurement, in the experiment concept, which is unknown, this is unknown. Why? Below 20, some X ols is given. Below 20, some X ols is given. Then this is known, and meter will show the pointer deflection. What is it? 1.5, 2.1.5, 1.7, 1.3, like that. It will show. That's why while designing, which is unknown, RSC is unknown based on our requirement. Yes, we have designed. After designing this, we place this resistance over here. Then give the X value, find out the corresponding value. Y value, find out. Z value, find out. Like that, we are keep on taking the value. Clear? Right. Here, this is not measurement. It is one of the processes of measurement. One of the process of measurement. People are saying that, sir, as we are not measuring, why are you extending? If we extend this only, then only you'll get the larger value. Measurement, I first class will tell you, measurement means instrument observation will be there, noting down will be there, calculation is also there. In this, every step we are doing. First class only I told you, sir, instrument gives this value, observe it, 1.45. Note down the value, 1.45. Third step is calculation. Yes, what is it? This is 18 by 2 plus 1. Starting days I told you, error analysis, gross error I told you. 3 steps will be there: observation, noting down, and calculation. We have done everything. Therefore, this is also the complete process is called as measurement process only. We are saying measurement process only. We say that. One thing. Second thing, still people are having general doubt, sir, we are calculating. No, we are calculating. That is a process called as calculating only. If that is the case, simple example, electrical example I'm giving. Concentrate. Right here, the point here is, suppose in your missions laboratory, for example, right, Swinburne's test is there. Okay, Swinburne's test of a DC machine means no load test. In that, what you get? I naught you get, some V1 you get, something will get. After doing the experiment is very, very simple. Only one reading. Within 5 minutes, experiment will be over. But you will be staying in the missions lab for 2 hours, 40 minutes of time. Why? Means after this entire thing, no load. Based on this no load value, 1/4 full load, half full load, 3/4 full load, and full load. Like this calculation we will be doing. Finally, efficiency is this. Like this. Sir, if you are getting efficiency, can you say you are not measuring the efficiency? You are calculating the efficiency. It is wrong. Come on here. Experimentally, what will be there? These values will be there. Mathematically calculated should be these values. That's why finding something means observation may be there. Observation plus recording plus and calculation also may be there. That is what this entire extension of range process. So this is the total discussion regarding extension of range of PMMC instruments. Clear, right? Clear, guys? Right. Here, people are having this doubt. Come on here. Sir, why we are connecting in series? Why we are connecting in parallel? Electrical people. Just I told you, large current should be divided parallel. Large voltage should be divided. Voltage will be divided only in which connection? Series connection. Series connection. Clear? Right? So this is a total discussion regarding values. Now, to avoid all varieties of confusions, right, I'm taking one simple question. Right. This is the question. Very good. Poloji Megana, right? According to the supply only, that is what our requirement. According to the supply only, you need to go for RSH or RSC value. Correct. That is what the point. Right. In this way, the questions will be given. Concentrate. Sir, what is the value of series resistance to be used to extend 0 to 200 volt range voltmeter? Means what is the VM value they have given? 200 volt is given. So VM is known or unknown? VM is known. Come on here. We have the voltmeter. If you see the full scale value, can't you know corresponding VM full scale value given or not? Yes, this is it. That's why here 0 to 2 I have taken. 0 to 2 is the full scale value. Yes or no? Here also 0 to 1 is the full scale value. That is by seeing the device we can understand. Okay, right. 2, what is that? Which is having the sensitivity of 2000 ohm per volt. Right? Which range? 0 to 2000 volt means V is given as 2000 volt. They're asking what is RSC. What does it mean here? Sir, in this entire discussion, what is that? VM200 means we have a device which is having the full scale value of 200. It must be extended up to 2000 volt, right? Okay. What is the formula? Just now I told you, RSC is equal to REM into V by VSC minus 1. Okay. Sir, what is V? 2000. What is VM? 200 minus 1. Okay. But sir, what is REM? REM is not given directly. See, VM full scale value. What is it? 2000 ohm sensitivity, 2000 ohm per volt sensitivity. That's why by utilizing this, what we can write here? REM is equal to which value, guys? REM is equal to, what is the formula? Here 2000 ohm per volt into 200 volt. Why? It is a sensitivity of the meter. This is the full scale value of the meter. So what is the value now? 400 kilo ohm, or we can write 0.4 mega ohm. Right? Now, actually, this is a step you have taken already in the earlier chapter. It's a repeated. What is that? 0.4 mega ohm. Finally, 9 into 0.4, so therefore 3.6 mega ohm. This is the value of resistance required to the extension purpose. Yes. Many people have given. Yes. One second, sorry. I told VM only, but I have written VM only. V by VM. In this way, what is it here? Available range is given to you. Available instrument capacity, by seeing that you can know up to which value you want to extend, that also will be given, and meter resistance also given. So what is the value of RSC required to have the safe operation is this one, right? Let me take one more question. Very good. Many people give the correct answer. Correct. Very simple. Simple question. Sir, first let us write the given data logically. A DC voltmeter has a sensitivity of 1000 ohm per volt. Okay. Sensitivity is 1000 ohm per volt. What is that? When it measures half full scale in 100 volt range, therefore full scale value is 100 volt. When it measures half full scale in 100 volt range, what does it mean? In the 100 volt range, half value they want to measure. Yes or no? The current is dash. So therefore, what is that? Half full scale value, that is 50 volt they want to measure. What is the current we require? Very simple. But sir, sensitivity of the device is given. S is equal to 1000 ohm per volt is given. Sir, from this 1000 ohm per volt, 1000 ohm per volt, what is the IFSD? IFSD is equal to 1 by 1000 means 1 milliampere. Indirectly, simple logic. Indirectly, what he has given here? For measurement of 100 volt, 1 milliampere is required. For measurement of 50 volt, how much current is required? Very, very simplest question. But question terminology is twisted. Solution is very, very, very simple. Yes. Therefore, I is equal to what is the value? 0.5 milliampere. 0.5 milliampere. Clear? Right. Right. So and so waveform is given. It is asymmetrical waveform. So therefore, average value cannot be zero. Randomly I'm saying. What is that? This is the waveform given to PMMC. This is the waveform given to permanent magnet moving coil instrument. Then PMMC reads average value. So what is its average value? What is its average value? What is its average value? Right. First of all, every one of you, electrical as well as IN engineers, should remember one basic electrical point. Sir, average value will be defined only for one cycle, not for multiple cycles combination wise. So therefore, this is one cycle. Okay, right. Sir, solution I'm giving. PMMC anyway reads average value. Current is given. I average is equal to. If waveform is given, how to determine the average value means, see this portion, whatever this portion is there, find out the area of this portion. Find out the area of this portion. Yes or no? The formula of finding the average value, it will be there in the network theory, no need to worry. The formula is area by corresponding time period. So what is the area? This is half BH, right? Half. Base is 0 to 1 into height of this one is also 0 to 1, only this one, triangle 1. And so what is the area of this portion? What is it? 1 to 2, 1, and here 0 to 1, 1. So therefore 1 into 1 by 2. But here very, very important, sir. Triangular portion is on the positive side. So therefore take it positive. Take it as positive. Sir, the rectangular portion, square type portion is on the negative side. You have to take negative. That's what the area means. Sum of the total area. So simply, this is half minus 1, half by 2. So simply minus 0.25 amperes. Minus 0.25 amperes. This is the earlier paper question, GATE 17 question. Yes, many people give the correct answer. Only 1 or 2 people give 0.5 as the answer. Means they have forgotten this one. 2 time period, I think they might have forgotten that. Clear? The minus sign indicates that the negative portion of the given waveform is larger than the positive portion of the given waveform. That's it. Okay, right. Next, let me take one more question. After the topic, I'll be taking the questions like this, as many as possible questions. Same model, but figure is different. Right, same thing. Sir, PMMC average. PMMC average. Right? Okay. Now the question is, sir, area under the waveform by time period. See, total thing is one cycle by no repeated waveform. So denominator is 20. Now, the first portion, triangle area, half into base 10, height 10, half into base into 10. Right? After that, area of this rectangle, bottom side 5 and horizontal side 2. So therefore, 2 into 5. 2 into 5. After that, sir, 12 to 20, 8 into 5. 8 into 5. Okay. Now, sir, triangle is on positive side. This small rectangle is on negative side. And one more square type rectangle is on the positive side. Now, final value is how much? This is 50 minus 10 plus 40 by 20. What's the answer here? 4 ohm. 4 ohms. Right? Okay. Now, one small doubt is there with many people. Yes, I'm going to clarify with one more numerical question. One more numerical question. Sir, here with that, everything will be clarified. Everything will be clarified. That's why I told you the time comes, I will explain one by one. What I have taken minus 0.25. Options it is there or not, it is there. Leave it. Okay. After that, something else is or not teaching means it will be taught later. Fix it, fix it. Don't type the message continuously. Okay. Right, sir. I of t is equal to I of t is equal to minus 8 plus 6 root 2 sine 314t so many amperes is given to first one PMMC. So what is its reading? Second one, I'll tell you, right? Be clear, let's be clear. Sir, PMMC reads which value? Average value. Okay, right. PMMC reads average value average value is minus 8 amperes. Minus 8 amperes. But, sir, minus 8 means negative current. But our PMMC is 0 to full scale value structure. Sir, this is at 0. This is at 0. Which current is there? Negative current is there. Negative current into flux density, negative torque. Therefore, the torque will be produced in this direction, backward. But sir, below 0, do we have any scale related to this? Below 0, do we have any scale related to this? There is no scale. That's why even though average value is minus 8, even though average value is minus 8, what we should say? PMMC instrument reads 0 only. PMMC instrument 0 only. Why? It is at 0. Negative current is there. That negative current will move the pointer below 0, tries to move the pointer below 0, but below 0 scale is not there. That's why it reads 0 only. One thing. I'll go back again, no problem. Second question, what I'm giving, center 0 PMMC. Center 0 PMMC is given, for example. Okay. Again, average value is, I average is undoubtedly minus 8 amperes. Okay, no problem. But what is the scale? Center 0 PMMC is not there. What is it center 0 called? We'll see that later. But in the question, center 0 PMMC is given, means center 0 PMMC means DC structure. That's it. So therefore, center 0 DC type of device is given. This is 0. This is positive side. This is negative side, for example. Now, in this device, pointer will move below 0. Yes, chance is there. Therefore, what is it here? The pointer will be coming over here. What is this? 8. It will be looking 8 only, but negative side minus 8. So therefore, what we can say now? It reads, this PMMC instrument reads which value? Minus 8 amperes. Okay, right. Now I'm going back. Sir, in this question, do we have 0? No. Do we have whatever the value you got? Yes. So therefore, minus 0.25, you take it as it is, no problem. Suppose instead of this, if 0 is there, obviously 0. But don't get the controversial questions, because IIT people will set the paper. So standard will be there. There is no ambiguity, etc. No need to worry. So therefore, kindly don't get things like, so this is given, this is also given, which is correct. Like that, they will not give definitely. Because see, any one of the option will be given. Either 0 will be given sometimes, otherwise value will be given sometimes. One thing. But people's doubt is, sir, if this is there in the numerical answer type question, if this is there in the numerical answer type question, then what we have to answer? Numerical answer type question, what we have to answer? Be clear. Whatever the value you get, that only you need to indicate. Whatever the value you are getting, that you indicate, no problem. They will give the mark, you need to work. But what is the meaning of this? This entire complete mathematical analysis. Okay, sir, negative current is there. If negative current is there, right? Negative current cannot be measured by our normal PMMC device. Negative current is not measured by normal PMMC device. How do we measure? Means simply, whatever the terminals are there, this is plus, this is minus, this is plus, this is minus. Supply will be there, no? This is to the load, like this will be there. Is that no? So how do we connect this meter? Means here, positive is connected here, negative is connected over here, positive here and positive here. So therefore, if you reverse the corresponding device, what is it here? So far, current has flowed from which one here? Positive to negative. Generally, current will flow. But now, negative to positive means that current is reversed, means reverse of reversal one, simply positive torque. Then, yes, this is 0. It will show the 8. That is what the meaning. Negative value indicate. People ask that, sir, what is a negative and negative value indicate? Means negative sign indicates the current is in the reverse direction. If you want to measure this current, we need to reverse the terminals. That's why you need to take as it is current. Clear? Okay. People are asking, sir, even after reversing that, it will show +8 only, but not -8. Yes, but we know that this is the 8 shown by the device directly, not directly, after reversing one of the coils connection. Therefore, this is 8 only, but after reversing -8, that's it. That is what the actual meaning of negative sign. Many people type the continuous messages. When the time comes, I will explain. That's why I gave this question. One more question I gave you. After that, in this more clarity, normal device 0, center 0, PMMC. What is it? -8, -8. Suppose if this question is given in the multiple choice questions, instead of 0, if -8 is there, you answer it. Because if instead of 0, -8 is there, you answer it. What does it mean? Okay, negative current is there. Terminals of the PMMC will be reversed. Therefore, reversal of reverse means what? Forward. The pointer will be moving in the forward. So this is the total concept related to the entire PMMC instrument. Clear? This is a total concept and numerical questions. And we will see further more numerical questions later, but only topic to topic few I'll give you. At the end of the chapter, all the questions together will solve. Okay, this is the total discussion regarding PMMC. Now, let us take next device, moving iron. But I know the moment I'm going to moving iron means people will ask, sir, in the PMMC, you told that coil and spring both are in series. I will tell you after the MI, because if I want to explain why the spring carries, how the spring carries current in PMMC, I should compare with MI. Every topic will be taken in the class step by step, the topic will be built up. No need to worry. Okay. Now I'm taking the second device. Still, we have not taken advantage of PMMC. Disadvantage we have not taken. We'll be taking MI. After that, few things will be compared with respect to PMMC MI. We'll take. After that, we'll take EMMC. After that, we are going to compare all the three devices, advantages, disadvantages, and corresponding applications. Everything will be covered, because if you want to say advantages of one thing, you should know some other method. They compare to that method advantage, compare to the method disadvantage, like that. Some other thing we know, but right now we know only PMMC. We don't know anything else. That's why let me take moving iron instrument. Moving iron instrument. Now, in this moving iron instrument, what is the corresponding torques required? All I told you, the torques required are deflecting torque, controlling torque, and damping torque. Deflecting torque, controlling torque, and damping torque. Clear? Right. Right. Whatever the answer you are getting, I'm repeatedly saying, all I told you, whatever the answer you are getting, write that only. Don't worry. Okay. Right. Based on options, you can choose it. Now, sir, in the moving iron, TD, right? TC, damping torque. Okay. Sir, what is TD? Moving iron. Yesterday's class I told you, deflecting torque setup, magnetic effect, permanent magnet, moving coil, PMMC. Other thing I told you, electromagnet and iron piece. So therefore here, one electromagnet means coil only, coil, and one iron piece. All I told you, operation will be same. Why? Supply is given, TD first, later TD, built up and equated to TD, and then oscillations, then it will be nullified by what's your damp. That's why I told you already, yesterday's class, I spent TD, TC, damping torque, same operation. But here, construction based on it corresponding mathematics is different. That's it. Okay. Now, controlling torque, which one? Spring control torque. Control torque is spring control torque. Damping torque, which one? Air friction damping torque method. This is all I told you. Application is tool, air friction. Now people are asking, sir, why don't we prefer eddy current? Eddy current damping means what we require? Permanent magnet we require, but permanent magnet is not there. So therefore, after the eddy, which is preferred? Air friction is preferred. Okay. And after that, very, very, very important, sir, electromagnet. Which magnet here? Electromagnet. Sir, electromagnet means magnetism is varying with the supply, or magnetism is constant means magnetism varies with the supply. So therefore, whatever the magnetism is there that varies with the supply means it is suitable for DC as well as AC. Why? AC positive of cycle. According to the positive cycle of current, magnetism will be there. According to the negative of cycle of the current, magnetism will be changing. But in the permanent magnet, whether you give positive current or negative current, flux density is always called. That's what I told you. Positive into positive, forward. Positive into negative, backward. Here also, same concept. But here, based on the current, flux will be changing. Flux direction will be changing. Positive current, yes, positive flux. Negative current, negative flux. Positive into positive, positive. Negative into negative also, positive only. That's why MI instrument is applicable for both DC as well as AC. Right? Next, here I'm writing magnetism varies with the supply. What do you mean by that? Magnetism varies with the supply means magnetism varies with the supply means the magnetism follows the supply variations. Magnetism is following the supply variation. That's what the point. Okay. Therefore, what is it here? Yes, applicable for both DC as well as AC. So therefore, right, it is applicable for DC as well as AC. Sir, it is applicable also for AC means yes, it is perfectly following the AC supply variations. Therefore, AC it is applicable. What does it mean? Yes, RMS values measurable. That's why simple logic. If we give DC, it measures average value. If we give AC, it measures RMS value. If we give DC, it will measure average value. If we give AC RMS, why? This is suitable for AC supplies, but this is not there in PMMC instrument because in the PMMC, magnetism does not vary with the supply. Yes or no? Here, magnetism vary with the supply. Now tell me, for AC supplies means my question is RMS measurement. For RMS measurement, you prefer PMMC or MI means obviously we prefer what is that? MI instrument only because in this electromagnet is there. People are asking immediately, sir, why don't we use electromagnet in PMMC? Name itself is permanent magnet moving coil instrument. Therefore, internally, permanent magnet is there. Permanent magnet is there. Okay, right. And one more thing. People general doubt. In few textbooks, spring or gravity is also given. You can use anything, but all I told you, earlier topic only I told you, if you want to use gravity, you can use, but drawbacks will be more, errors will be more. But generally, in textbook, in moving iron instrument, gravity control also preferred. Sometimes it is given, but strictly speaking, actual answer is spring control method generally. Why all I told you? If you want to use the gravity control method, you can use, but we don't prefer. What do you mean by that? Using loss is more or less, no problem. But preferring loss is more, no preference. Loss is less, yes, prefer. That's why the spring control only we say, but wherever gravity control is mentioned, no problem. Okay, losses he is accepting, no problem. No problem. Simple logic here. We are running one business. Suppose 1 crore business we have started 1 crore business, for example. 1 lakh loss happened. Do we accept it? No. Suppose 1 lakh crore is there. Suppose 1 lakh loss is there. compared to this, it is very less or not. So that's why error we can continue or we can not continue. That depends on the main value approach. Simple logic. That's why here last content is same, but compared to 1 crore, this is almost high value. Compared to 1 lakh crores, 1 lakh is very negligible, very negligible. If you are not clear with this, one more example, sir. I have 1 rupee. I have 1 rupee, only 1 rupee. Only 1 rupee is with me, right? Suppose 50 paise is lost. Definitely, of course, nowadays 50 paise is not, but example, definitely full pain will be there. Okay, suppose I have 1 crore rupees. If I lose 50 paise, nothing will happen. Isn't it? Why? Compared to 1 crore, 50 paise is very, very negligible. Here, 50 paise is 50% of this one. So that's why always be clear. If you want to go for gravity as a textbook, no problem, but errors will be more. That's it. You want to continue, you can. Otherwise, strictly speaking, generally we don't prefer we say. Clear? This is a complete introduction regarding moving iron instrument. Okay. Now, in this moving iron instrument, there are 2 types. Very, very simple. Attraction type MI means 2 types of structures. Construction is only different. Operation all will be same. Attraction type and repulsion type MI. 2 types are there. So what are these? First of all, let us take. So very, very simple. Here, what is the device name? Moving iron. Iron piece should move. Moving iron means iron piece should move. Okay. Iron piece should get deflected. Based on the iron piece deflection, spindle and pointer will be moving and spindle will be rotating. As the spindle rotates, spring gets disturbed. Based on the spring disturbance, opposing force, and finally both are equal. Pointer tries to oscillate. Air friction damping. Overall principle is same. I'm repeatedly saying this. Overall principle is same, but only construction wise we need to study again. That's it. It is only revision point only operations. Okay, right, sir. In the attraction type, what is a construction parameter means here? 1 current carrying coil, 1 iron piece, 1 iron piece. Okay. After that, very, very important point is, see, if this is the coil, my hand is coil, this is iron piece. If I place in the magnetic field, definitely it will be attracted by the magnet or not? Yes. So that's why what we can write now? Attraction takes place. Attraction takes place between which one? Coil, that is magnet, and iron piece. PC means piece, iron small vein, or iron vein or iron piece, we can say. This is what the first point. Okay, but repulsion principle, concentrate. In this, 1 current carrying coil, 2 iron pieces. 2 iron pieces will be used. Out of those 2 iron pieces, 1 is fixed iron, 1 is moving iron. One more thing you have to concentrate. Sir, moving iron means iron piece only moving, coil will be fixed. If the coil is also moving, that is called as moving coil instrument. But this is not moving coil, this is moving iron. So iron is moving. In this also, coil is fixed. 1 iron is fixed, no problem. But other iron piece is moving. It finally, iron piece is only moving. That is what moving iron structure. But be clear, guys. Sir, how the repulsion, where the repulsion, in between which parameters repulsion takes place? That is what very, very, very important point. Simply 1 coil. Okay, right, sir. Repulsion, where means concentrate. repulsion takes place between two iron pieces. Between two iron pieces means everyone listen this 1 minute statement. See, in this the manufacturer designs the device such that iron piece should be attracted by the magnetism of the coil. Therefore, the movement is based on the attraction. Therefore, the name is given as attraction type MI. In this repulsion type device, the manufacturer construct the devices such that both iron pieces get same magnetic field when those are placed in the corresponding magnet. Means both iron pieces are magnetized in the same way. Sir, similar polarities always attracts or repels. That's why repulsion takes place between fixed and moving iron. That's why is repulsion takes place between two iron pieces. This is what the corresponding total introduction. Okay, only I already told you, construction is different, but overall principle is same. What is that? Supply is given, coil gets magnetized, right? This magnetism is linking the iron piece. So iron piece is but getting attracted. Iron piece experiences a force by the corresponding coil. Iron piece gets deflected towards the coil. Same thing. What is it? The iron piece gets attracted towards the deflected towards the coil means pointer starts moving, spindle starts rotating, springs starts getting disturbed. Therefore, opposing force starts building up. Therefore, that opposing force is built up, gradually built up until that value is equal to TD. If both are equal, then what happens here? Due to that inertia and all, what is that? Pointer oscillation will be there. That will be nullified by which one? Air friction damping chamber. Here also same thing, but I'm repeating again. Concentrate. Supply is given. Coil gets magnetized. Based on this magnetism, two iron pieces get some pole strength. Means iron pieces are placed in the magnetic field, pole strength. But both iron pieces are placed in the magnetic field such that both should get same magnetism. Both should get same polarity. So similar polarities repel with each other. Therefore, the moving iron, suppose this fixed iron, this moving iron will be repelled back. As the moving iron is repelled, like this, what is it? The pointer starts moving, spindle starts rotating, springs gets disturbed, and those springs disturbance will build up the corresponding opposite force will be equal. Pointer will be trying to oscillate, then air friction damping torque. This is the complete operation of these two. Only the construction is different. I'm going to show that. But operation is same. I'm repeatedly saying here, yesterday's step-by-step topic, TD, TC, damping torque, step-by-step you have taken. No, very important. I don't know how many have you revised after the class, but that is very important. That almost 4.5 hours on that topic only 3. TD, TC, damping torque I spent. Okay, right. Now I will show, actually figure is not required, but idea purpose I'm showing. I'll show the figure of these two. One second. Can you wait? See, this is the corresponding figure. Attraction type MI. See, this is attraction type. I will show other thing also. One second. This is attraction type MI figure, right? I will show repulsion type also. Then I can compare these two. repulsion type Mi. I will explain all the things at a time, no need to worry. And both are also in other view, top view, front view, like that other view I'm taking. Right now, concentrate. Very, very simple. Sir, this entire thing is coil, right? This is outgoing current, incoming current, like that. I'm taking one coil like this, complete coil, right? So this is a magnet, so that's why supply is given. Yes or no? So incoming, outgoing, like this. The thing is happening like this. So therefore, the supply is given. It gets magnetized. But you need to understand this clearly. Kindly look at me once. Everyone, look at me in the video. Kindly. This is a spindle. Everyone is visible, I think. This is spindle, right? My finger is iron piece. I'm placing the iron piece like this. This is my finger. I'm placing the iron piece like this. Okay. So if the spindle is rotated, the finger is also rotating or not? Yes. What is it? The spindle and iron piece both gets rotated together. Okay. Right. Sir, suppose my hand is coil. Can you look at the video? This is coil. I have shown there, but I'm trying to visualize it here. This is coil, and this is like this. This is like this placed. Okay. Right now, the moment supply is given to this coil, magnetization. So therefore, due to this magnetic effect, iron piece gets attracted. Then what happens here? Simply the iron piece is getting rotated like this. Getting rotated means like this iron piece was there. Now this iron piece is moving like this, means rotating. This means, is it moving towards the coil or not? Yes, that's why iron piece is getting attracted. The three-dimensional picture I've shown here. This entire thing is spindle. To the spindle, SID means soft iron disc, means normal, small, lightweight iron disc, right? That iron disc will be, suppose this is the iron piece, for example, like this. It is keep on getting rotated like this, means this is keep on getting moving. How? Based on the magnet. Yes, iron pieces keep on getting rotated like this. Nothing but which principle? Attraction. How can you say this iron piece is moving towards the corresponding coil? But be clear, moving means not linear movement here. It is angular movement only. Like this, it is moving. Angular movement. Yes. So on the spindle, it is placed angularly. It is moving towards the corresponding coil. The moment it moves, what happens? The spindle rotates. Yes, pointer starts rotating. Means TD is produced. Immediately, springs gets disturbed. Yes or no? Thereby, TC will be produced. If both are equal, someplace they will be stopped here or here, someplace they will be stopped. Right now, tell me, everything is same or not? Overall operation is similar or different? Overall operation is exactly similar. Overall operation is exactly similar. Okay, one thing. Second thing, sir, at this point, it is getting oscillated. At this point, it is getting oscillated. If it is getting oscillated, what happened here? Yes, air friction damage. See, very, very small chamber, small capacitor also told you. This is air friction chamber. Based on these oscillations, what is it? Piston tries to move in, come out, move in and come out. So automatically, what is it? Yes, due to the pressure development, the spindle will be stopped, pointer will be stopped, thereby pointer will be stopped. Okay, therefore we can stop oscillations. This is the complete attraction principle structure. Okay, that's why I told you only the construction is different. Only the construction is different. Clear? Right. Yes, only the TD production structure is different from PMMC. In the PMMC, permanent moving coil, but here fixed coil, iron piece, but overall concept is similar. This attraction type. Coming to repulsion type. Sir, repulsion type. Be clear, guys. Be clear. Sir, two iron pieces will be placed. Concentrate. This iron piece is fixed iron piece. Fixed iron rod. Concentrate. This iron piece is connected to which one here? Connected with this structure. This structure is which one here? Coil. This structure is coil. So that's why try to understand. You see here, this iron piece, this entire thing is iron piece. This is the iron piece connected with respect to the coil. So therefore, that is fixed coil. Fixed coil, and iron piece is also fixed only. Iron piece also fixed only. Clear? Okay, sir. One more iron piece is this. This iron piece is connected with which one here? Spindle. This iron piece is connected with spindle. Okay. Now, same concept, sir. Supply is given, right? If the supply is given, this is the coil, no? Yes, this is the total coil. This is phase, positive, neutral, negative. Okay. That I'm showing with cross and dot symbol. The power, what is that? Current is flowing means this entire structure is acting as a magnet. Okay. In that, these two iron pieces are placed in the magnetic field means these two will be getting same magnetic polarity. Suppose north, south, south. Similar because both iron pieces are placed under the same magnetic field. So both will be magnetized in the same manner. Now tell me, this is the fixed iron piece. This is the moving iron. What happens, sir? Suppose here, this is a fixed iron, this is a moving iron. So automatically, both iron pieces will attract and repel means fixed. Same polarity is there. Now, this iron piece will be getting repelled other side. Repelled. Therefore, what is it? Movement is taken place with the repulsion. Movement is taken place with the repulsion. Therefore, repulsion type. Other than that, everything is same. Sir, repulsion movement, pointer starts moving. Then spring starts getting disturbed. Due to the disturbance, TC starts building up. Therefore, at one point, both will be equal. Both will be equal. Automatically, air friction chamber is already there. No, that will be correspondingly stopping the pointer. So that's why overall operation is same. Overall operation is same. Attraction, repulsion type, both are equally good. No need to worry. Both are equally good. But people are thinking that, okay, iron piece is moving means only by the attraction. No, iron piece will be moving by repulsion also. That depends on the construction. Okay. Now I'm showing both in one figure. Both in one figure. In the other view. In other view, I'm showing. See, this is the coil. This is the coil. Okay. Iron piece is there. This curved portion is there. No, iron piece. This curved portion is iron piece. This iron piece will be attracted towards this coil. Attracted. As it is attracted like this, the pointer will be moving in this direction. Yes or no? As the pointer is moving, whatever the spindle is there, rotated, springs will be getting disturbed. Disturbed means opposing for common. At one point, it is trying to get oscillated. Yes, air chamber will come into picture. Will be coming into picture. This attraction type. Okay. Now, repulsion type in other way I'm saying. See, whatever this cut section is there, no, this is coil. This is coil. Check. This is coil. This is circular outer structure is coil. Coil is which one? Fixed one. Okay. Now, concentrate, guys. This shape is there, no, like this. This shape element, that is the fixed iron. See, this is the fixed vein. Fixed iron means this entire thing is connected to the coil because both are fixed. After that, this vertical rod is there, no, that is spindle. See, to the spindle only this plate, this type of shape plate. Yes or no? That plate is connected to the spindle. Okay. Now, sir, this fixed vein, this moving vein, nothing but moving iron, both are in the same magnetic field. If both are in the same magnetic field, both are getting same polarity. Thereby, repulsion takes place. This will be keep on getting repelled outward from the corresponding this fixed vein. If it is repelled, same thing. Spindle gets rotated. Springs will be getting disturbed. Thereby, TDTC, everything is same. Okay. One more view also I'm showing, sir. Here, what is this? This entire circle is coil. This small box is there. This small box, that is fixed vein, fixed iron, and the center point is spindle. Connected over here is vein, moving iron. This one here to here, moving iron, and correspondingly springs are. Okay. What is it happening now? These two iron pieces are getting repelled, but this is fixed now. Yes, it will be moving away from the iron piece, moving away. Thereby, rotation is being started. That's why Only construction is different. Other than that, complete operation, everything is similar. Everything is similar. Clear? This is the complete construction operation. Both are equally good, no need to worry. Right? Now, let us talk about the mathematical discussion. What is it? Sir, deflecting torque. Deflecting torque. Sir, complete mathematics I'm giving here. Even though in the gate exam, you don't have the complete derivations and all, but here in this derivation, mathematical derivation concept is there. In the mathematical derivation, concept is there. So let me take the concept for mathematics for 2-3 minutes. After that, I'll come back and I will explain the complete concept. Clear? Right, sir. V is equal to L di by dt is a general formula, you know, but strictly speaking, V is not just L di by dt. V is something else. V is something else. Sir, what is that? What is that? Be clear, guys. Be clear. Actually, it is not just L di by dt here. It is d by dt of Li. D by dt of Li. This is actual formula. So after that, if I apply U by V notation, if I apply U by V notation, one second. Right, okay. So here, what is it? L di by dt plus I dl by dt. L di by dt and I dl by dt. This is what the general formula. But in your entire network theory, or you take any other subject, this will be taken as 0. This will be taken as 0. Why? Means in your network theory especially, L was the fixed one. L was the constant value. But in our measuring instrument, in our moving iron instrument, the L will be variable. Inductance of the entire system will be variable. How? I'll explain. First, let me take mathematics first. This is V. So therefore, V into dt equal to LDI plus I dl. So V into dt, no formula. So that's why I'm multiplying with V into I into dt is equal to Li di plus I dl. Li plus I, so I square dl. Okay. So this is one formula. Only mathematics. After this, complete conceptual expression will be given. Sir, V into I into dt. What is that? V into I into dt. What is it here? Energy. V into I into dt is energy. Okay. V into I power into time is energy. Sir, what is energy? What is energy? Means this is the energy input given to the device. How much time? dt. So therefore, energy supplied in dt second. Energy supplied in dt seconds. Clear? Okay. After that, sir, what is that? Energy stored formula. Energy stored by inductor only. Coil means inductive element. Energy stored in t seconds. Energy stored in t seconds. What is general formula? Everyone knows that half Li square. Half Li square. Energy stored is half Li square. Clear? Okay. How much time? T second. That may be any time. Some simply T seconds. Okay. Sir, energy stored in T plus dt seconds. How can we write? T plus dt seconds. Very simple. Sir, time of operation was T. Now, T plus dt second means time of operation is increased by dt. Time of operation is increased by dt. So if the time of operation is increased by dt, definitely current drawn will be increased, isn't it? And energy stored will be increased. Energy related element also will be increased. That's why the simplest term is, what is it? Half L becomes L plus dl, because small change in time. I becomes I plus di. Only I'm taking mathematics. After that concept I'll tell you. So time of operation is increased. Current drawn will be increased. How much value we don't know. Some di. But I'm not saying that this is dt 3 second. Di should be 3 amperes. No. dt is some time. Di is some current. That depends on the system capacity. In the same way, what is it? Energy related parameters also changing. Why? Current drawn will be changing. So automatically L also get changed. Okay. Now I want to get energy stored in energy stored in dt seconds. I require energy stored in dt seconds. Sir, what is this energy stored in dt seconds? Concentrate. Sir, this is energy stored in t plus dt second. This is energy stored in t seconds. So automatically, if you want to have dt, t plus dt minus t, tt will be cancelled, dt will be there. So therefore, half L plus dl, I plus di whole square minus half L I square. Half L I square. Clear? Okay. After the simple mathematics, a plus b whole square, you simplify this, you simplify this. If we simplify this, the two here. Sir, can we neglect di square value compared to I? Yes. Why? Suppose I is 10, for example. Di means small current only. No. Let me take 0.1 something. 0.1 square, 0.01. 0.01. So 0.01 compared to 10, blindly neglected. By taking this entire concept, right? If you simplify that, we are going to get energy stored in dt seconds. Energy stored in dt seconds is what you're going to get, here LIDI plus half I square dl you will get. This is energy stored. Simple mathematics here, nothing more than that. Only, what is it? A plus b whole square, and then multiply, and whatever the smaller values are there, di square into dl, or di into dl. What is it? 0.1 into 0.2, 0.3 into 0.2, like that, very small, neglected. If you neglect that, this will be the value. What is this? This is the energy stored in dt seconds. Okay. Now I'm taking this equation as first equation and this equation as second equation. Okay. Now, sir, I want to find out energy stored in energy output, or we can say mechanical work done. Sir, why? Means in the instrument, what is the energy output here? Pointer movement only, pointer deflection only. That's why what we can say energy output or mechanical output, or we can say mechanical work done. In how much time? dt seconds. How much time here? dt seconds. Sir, what is the work done formula? Force into distance. What is our force? Deflecting force, angular force. Sir, in dt seconds of time, how much displacement will be made by the pointer? In dt seconds of time, how much displacement will be made by the pointer? Means d theta, we don't know, small value, simply td into d theta. This I'm taking as equation 3. Simple mathematics of the field. Now I'm giving the concept here. Concentrate. Suppose instrument is operated for t seconds. instrument is operated for t seconds. What is energy? Half Li square. After the t second, concentrate guys, after the t second, right? We are utilizing that instrument for, we are operating that instrument for how much time? Dt second. Means in the dt seconds of time, this is the input given. Okay. And in the dt seconds of time, this is the energy stored by the device. In the instrument, energy is stored means energy is lost in the instrument. And in the dt seconds of time, in the dt seconds of time, what is the output here? Means t seconds already over. Concentrate here. T seconds is a normal operation over some time. After that, a particular experiment is being started only for dt some time. Dt seconds of time, this is the input given, this is the loss occurred, and this is the output. So can we use energy conservation principle? Yes. So therefore, what we can write? 1 is equal to 2 plus 3. Sir, why? Here, this is supplied input equation. This is loss and this is output. Kindly concentrate. Here I would like to say one point here. Just a moment and switch on the lights. 1 second. Can you be online? Right. See, those who are sleeping, those who are not listening the class, kindly concentrate, because at this topic, one thing happened in the classroom class. See, if I say this, you cannot believe that. See, what happened, in one of the places, I don't want to mention the place, in one of the places, just 2 years back, I have completed this topic. After this topic, I gave the break. I went to faculty room and we were having a cup of tea and we were discussing. One student seriously entered into our faculty room, just pushed the door like anything, and he came into the room. Generally, doubts are there, the people will come to the faculty room and ask the doubts. In the offline class, I'm talking, in the classroom coaching. Right? That student told that directly by pointing at me. Kindly concentrate. What is the standard? What is the standard of concentration of the students nowadays? I'm saying that student told that, sir, you're wrong. Means the moment he entered into the room where we have almost 5 to 6 faculties, various branches, I'm electrical measurement, like that, measurement, different subject. Right? He told that, sir, you're wrong. I got confused. Where did I wrong? I was thinking that, okay, any plus or minus something I have taken, something I was discussing. He came to me, seriously, by notebook, he came to me. You don't believe this? Not for passing the time, I'm saying here, this is what happened in the classroom in one of the places. Sir, the student told that, sir, 2 और 3 को ऐड करें तो 5 आता ना sir, आप 1 लिख लिया, wrong है बोल के बोल. This is what the statement he has given in the break time. Means that is the standard of listening the class. Are you getting the point or not? Means what he's asking here, not any technical question. He is saying that, sir, 2 plus 3 equal to 5, but you written 1. So wrong, sir. Same statement, same thing given by the student. What should I answer? What should I answer them? This is what I'm not commenting his talent. I'm commenting his concentration. That's why this is a standard of listening the class and seeing. And sometimes in this batch also, sometimes people are switching on their video. Simply they are sleeping and they are keeping the mobile phone like this. They are watching like this. And they are asking the irrelevant questions. Not only to me, every faculty, same problem. This is the standard of listening the classes nowadays. Give his money back and let him go. So this is what the thing. What your answer means, I got relaxed actually. First of all, I got relaxed. And all the people, all the faculty, definitely. See, I know he's my student, okay, but all faculty laugh like anything because we cannot stop our laugh in that situation, right? Finally, I told him, actually, I should not say anything, right, as a faculty. Therefore, no, yeah, this is not number 2. This is not number 2. Yeah, this is not number 3. This is equation 2 last. Oh, okay, sir, बोल के चले गए. After this, okay, sir, right, okay, sir. Then he left this room. This is what the This is what the standard of listening the class nowadays, students. Not everyone, only one or two people. That too, okay. What should be the attitude of the student generally? Right, just come to the faculty. Sir, actually, this is looking like some problem, etc. But what he told, sir, you're wrong. Right? Pointing out like this, he came that too with full voice and he came. But this is the question he asked. That too, he is preparing for ESC 18 batch, means 2017 it happened. ESC. So kindly concentrate. Kindly, that's why I'm saying every time, listen, listen, listen. I'm saying for this purpose only. So kindly listen the class. See, that's what I'm saying. That too, offline means up to some extent our concentration will be there on your body language, etc. But this online, no, yeah, very difficult. You're sleeping or what are you doing? We don't know anything. Simply few people maybe only log in and keeping mobile aside, roaming in the home, going to water or going some fun, something, etc. Also maybe doing, and they'll come back and they will say, "Sir, my not you people generally, sir, my internet problem was there. Kindly repeat this, sir." This is what the problem. That is the reason why sometimes we need to reply angrily. Otherwise, people are not listening. Isn't it? If I keep on continuing that, you will be habituated to that. That is the reason why sometimes I'm saying that don't type like that, don't type like that. I was saying actually. Yes, Anusi, his confidence is more than his concentration. Very good. Yeah, that's what the thing. Actually, parents have full of money. That is the main problem. So this not parents' mistake, but generally full of money is there. Ah, okay, gate is not there. Papa ke paas both paise hai. I have my father more money with father. I can. That's what the thing. One thing. I would like to say one more thing because continuously subject is going on. One more thing. In one place, I don't want to mention the place because if any one of you from that place, you will feel bad. That's what. See, break time only 15 minutes of break. Generally, 15 minutes of break will be there. Just I went to the faculty room and generally people will come. Actually, 15 minutes break also we don't take properly generally because some people will come and ask the doubts generally. One student came and after this I'll be taking EMMC instrument. After EMMC instrument, almost 2.5 hours approximately 2.5 hours topic, complete questions and all. I gave the break. One student came to me in the faculty room and told openly that too. How dare the student? I don't know. Clearly said that, sir, see, actually, if doubt is there, how should you ask, sir, this topic is doubt, so that and I explain this doubt, etc. Okay, so the student told that, sir, I went to one party yesterday. I slept in your class. Kindly explain this topic completely. This is what the same statement I heard from the student in this way. Like the students are there. That's why. That's why I told every time. That's why I say every time. Common sense is very, very, very important, right? More than the subject, you need to have common sense first. Nagendra, I'm not here to pass the time. I'm saying something to change your mood. Wait, I know when to start. I know. Right. Okay. Now come back to the topic. Right. Why I'm saying means at least I should not expect the same question from your batch. That is what the point actually. This is what one is input, one is loss, one is output. Because I'm going now, sir. This is the input supply given to the device. This is the output response from the device. This is the energy stored in the device. Means concept is energy stored in the device means output it is not coming, so automatically loss content. So therefore let us substitute that input supply LIDI. After the mathematics, after the concept of time operation and all, I'm going back to again mathematics. LIDI plus I square DL is the first equation. LIDI plus half I square DL is the second equation plus TD into d theta. TD into d theta. Right now, sir, LIDI cancelled. Half I square DL, full I square DL. Half I square DL is equal to TD into d theta. Therefore, TD is equal to half I square dl by d theta. If I give this formula directly, right, my part will be over, but complete concept I gave you. What is it? Supply is given, and then energy is stored, and then energy output will be there. If you're combining all these, yes, we can derive the corresponding deflecting torque equation. So this is the deflecting torque equation in MI instrument, not blindly I have given. I have given by the complete explanation, complete conceptual explanation. Complete conceptual explanation. Clear? Right? Okay, right. TD equal to half I square dl by d theta. Okay. After that, again, conceptual topic. What is that? At final position. Otherwise, which control? Generally, spring control. Spring control. Right? In the spring control, TC is equal to TD. TC is equal to TD. Sorry. TC equal to KC into theta. After that, sir, at final position. At final position, what is that? TC is equal to TD. What is TC? KC into theta. What is TD? Half I square dl by d theta. So from this, theta is equal to half I square by KC dl by d theta. This is the theta formula. Obviously, first always theta is radians only. Unless and until it is mentioned as degrees or something, general radians. Okay. Now, be clear, guys. Be clear. Sir, here, half is constant. Okay. So, what about dl by d theta? I am assuming if, I will remove this, if later, if dl by d theta is constant, what is TD? Therefore, TD proportional to I square. TD is proportional to I square. Same assumption taking. Sir, half is constant. KC is anyway constant. If, same assumption, same. If dl by d theta is also constant. So same thing. What we can write now? Therefore, theta is proportional to I square. But concentrate. Sir, theta is proportional to I square. Non-linear, non-uniform, or which law? Square law scale. That only I told you in the, what is it? Error analysis chapter. Square law scale. Y proportional to X square scale. Nothing but MI instrument I told you. MI instrument I told you. So automatically, what is it? This is square law scale. Clear? Right now, sir, even though it is square law scale, concentrate. Deflecting torque is proportional to I square. Theta is also proportional to I square, means theta is following the TD properly, therefore working properly. This instrument is working properly. No need to worry. Clear? So this is a total topic related to what's the mathematics and corresponding concept. Thereby we got this equation. But sir, dl by d theta is constant or variable. I have written if, but dl by the constant or variable, concentrate here. Sir, here supply is given. Current, magnetic field. Current is a magnetic field. Okay. Magnetic field means what? Inductive based only. L. Based on this, what is it? Force or torque. Based on this, theta. This is what the simple overall shortcut, right? Current is given, magnetization, energy stored means inductance into picture, and corresponding force, attraction or repulsion, something based on that moment, theta. Deflection, angle of deflection, theta. Now, my question is, I'm increasing the current. Increased. Theta will be increased. More current, more deflection. Less current, less deflection. Suppose current is reduced. magnetization reduced, force reduced, theta reduced. So my question is, sir, these two are changing together or changing independently? These two are changing together. Why? D theta and dl both are changing together. Both are changing together. So that's why change in inductance to the change in theta. Nothing but change in theta is based on the change in inductance. Therefore, what is that? Change in theta based on the change in inductance automatically same. So therefore, this is generally taken as constant. I have written as assumption if, but strictly speaking, we can treat dl by d theta as constant practically in the moving iron instrument. But strictly speaking, not exactly constant. This is approximately constant. Why? Means this is the magnetic. This is the, what is it? Mechanical. Magnetic is purely based on current, instantly happen. But theta depends on pointer inertia, pointer weight also. That's why small difference will be there, but that change is neglected. That's why dl by d theta is approximately constant. dl by d theta is approximately constant, and we can treat this as dl by the constant. But idea purpose, I'm mentioning, I'm keeping if as it is, so that you can understand that it is not exactly constant, but approximately constant. Yes, we can treat that as a constant. Therefore, from now onwards, if you take any mi instrument related question, what is the formula? Half I square dl by d theta, and here half I square by kc dl by d theta. This is a complete information regarding moving iron instrument, basics point, construction and operation, and then mathematical deflectant torque equation. From that, we have got this. Okay, I will continue the further topic after the break. Take the break and come back for 15 minutes. We'll continue this. Right. Welcome back. What is the MI instrument scale? Square law scale, right? Right. And one few people told that, sir, we have seen gravity control method is used in MI. What I told you, in few textbooks that will be given, but generally we prefer which one? Spring control, I told you. But you go to the textbook wherever the gravity control is there, but still in those textbooks only same equation is given. Means what does it mean? Same equation is given means T is equal to Kc theta only, right? If gravity control means Tc equal to what is the formula? WL sine theta should be there. WL sine theta base formula will not be there. That's why, what is that logic? We can also use gravity control method, but preferable will be this one only. That's why you can take whatever may be the textbook. The statement may be given, gravity control also may be used, etc. But still, formula in the same textbook, in the same topic itself, they give this formula. What does it mean? Yes, simply this is spring control. Kc is there means automatically spring control only. That's what the simple logic. Okay, one thing. Now, the very important point. After that, I'll be going to the next topic in this MI instrument. What is it, sir? How the inductance is variable, right? I'll tell you here, everything I'll tell you. How the inductance is variable. Very important. People are saying that, sir, generally L is constant. Generally L is constant, but not in the moving iron instrument. Not in the moving iron instrument, because you take network theory, R, L, C. This is 1 ohm. This is 1 millihenry. This is 1 microfarad, etc. You are not having any moving object. You are not having any variable current, etc. Because for this supply given is 230 volt something. So therefore, even though it is AC, magnitude of current flowing through this entire structure will be constant. But in our MI instrument, which is there, coil is there. To this coil, suppose 0 to 10 is there, for example, 0 to 10 is there. We can give 1, 2, 3, 4, any number we can give. So as the current is changed, current flowing through the corresponding coil will be changing, magnetization will be changing. As the magnetization is changing, L is equal to N phi by I. Current is changing, phi is changing, automatically L also will be changing. But in your other, that's why I told you in the starting only, in other subject, network theory, whatever with the subject you take, you don't apply variable element, or you don't variable current, or you don't apply any moving object, etc. No way. That's why I'm giving the point now. Sir, why the inductance is variable? The simple point. Very important note. Sir, iron piece either getting attracted here or getting repelled here. Iron piece always moves towards, iron piece always getting moved towards low reluctance path or high reluctance path. Tell me everyone. Right, always iron piece getting the force from the magnet means iron piece always moves towards low reluctance path. Yes or no? This is very well known point, everyone. So therefore I'm writing here, iron vein or iron piece, anything, iron vein always moves towards the low reluctance path, towards the low reluctance path. Means concentrate here. Sir, this is the coil. This is the iron piece. This is iron piece. Sir, iron piece is getting moved like this. So no, attraction taking. Yes, iron piece is getting, sir, as the iron piece is getting moved like this, between these two, reluctance is getting varied or not? Yes, that's why iron piece, what is it, coil, iron piece getting the force, and therefore movement will be such that it is towards the corresponding coil only, towards the corresponding coil. Therefore, iron piece always moves towards the low reluctance path. Therefore, reluctance is getting varied. Yes, here more gap, and it is coming here means less gap. So therefore, simply L is equal to N square by reluctance. That's why, see, don't take everything same in every condition. No. Okay, now to understand this, one more example I'm giving. Sir, I proportional to, sorry, I is dash with respect to V, proportional to or inversely proportional to, which is correct? Proportional to or inversely proportional to? I is proportional to, inversely proportional to. Yeah, this is what the main problem, especially with our electrical engineers. Our electrical engineers. That few people, yeah, Likita and Mohammed Faizan Uddin, right? Correct. Right? See, I proportional to V is correct. I proportional to 1 by V also correct. Sir, generally I proportional to V. Yes, generally I proportional to V. When Ohm's law, when temperature is constant, when resistance is constant. But if you come for your power system or your transformer application where power is constant, P is equal to V into I. P is constant, V and I both are inversely proportional to each other. Both are inversely proportional to each other. So difference is there, no? That's why it depends on the given condition. In your network theory, there is no moving object like iron piece is moving, low reluctance, etc. Not there. Only in MI instrument, it is there. Okay. Second thing, if you take that, sir, capacitance value is fixed, no? In the network theory, capacitance value is fixed. Or you take any subject, generally, capacitance is 1 micro, 2 micro, etc. Fixed. But in our measurement, capacitance is variable. Sir, how? Means here, simply two plates will be there. This is the fixed plate. This is the moving plate. As the moving plate is getting deflected towards the fixed plate, distance will be varied. C is equal to epsilon A by D. D is varied means automatically C will be varied. That's why don't take everywhere universally. That depends on the given condition. That depends on the given condition. Clear? Right? Right. And one more general doubt. So that's why before asking the question, I told you to think once, twice, thrice, 4 times, 5 times, 10 times. Think and then only ask any corresponding faculty. A doubt is there, let us throw on him. Don't do that. First, try to understand. Try to understand. Here, this is the coil. This is the coil. Okay. This is the spindle. This is the spindle. Right? Okay. Right, sir. I'm placing one iron piece here, for example. For example. Okay. Otherwise, simply here. This is the coil. I'm placing one iron piece like this. This will be getting attracted. This will be getting attracted. As it is getting simple two-dimensional figure I'm giving. If it is getting attracted, what is that? Clockwise rotation. So therefore, pointer will be rotating clockwise. One student is asking that, sir, in the attraction type, the pointer is rotating, nothing but torque is in the right side direction. Yes, sir, but in the repulsion, come on here, this is the coil. This is the coil, right? This is one iron piece. This is one iron piece, for example. For example, this is fixed iron piece. This is moving iron piece. So between these two, repulsion. So it will be moving clockwise only. Don't take like attraction right side, repulsion left side. That depends on the physical body, no? Yeah. That depends on the physical body, how you are constructing, That's what attraction type. What is it? Yes, pointer is moving, the instrument is operating properly. Repulsion also, pointer is moving right side. Don't think like, sir, attraction right side, repulsion left. That is simply construction based here. Kindly, that's why kindly think once, then you will get the things. Clear? Right, sir. What is that? Iron vein always moves towards a low reluctance path. Therefore, what is it here? Reluctance is variable. As reluctance is variable, because number of turns constant. Therefore, inductance is also variable. So, therefore, what is that? L is variable. But this L is variable only in our topic. Not every topic L is variable. No, only in this topic L is variable. Clear? I told you it will be clear, it will be explained. So kindly wait until I explain. Clear? So now the total discussion of construction, operation, mathematics, and corresponding conclusion, derivation, and all we have taken, including how the L is variable. If this is clear, then only we can say, sir, if this one L is variable, this is there. Suppose if L is not variable, 0, 0, 0. So therefore, no picture at all. That's why in our instrument, fixed inductance will not be. That depends on the iron moment. The corresponding magnetization will be taking place. That too, 1 ampere is given, 2 ampere, 3 ampere, 4 ampere, 5 ampere. Definitely, L will be varied with respect to the corresponding current and with respect to iron piece moment. That will I give you here. Clear? Right. Finally, sir, theta is proportional to I square. Okay, non-linear, non-uniform square law. Okay. Suppose if I write like this, what does it mean? Ammeter. This is ammeter. Okay, right, sir. If I write theta proportional to I square, proportional to V square, or sometimes in the textbook it is given as theta proportional to V square. Maybe I square proportional to V square. Therefore, voltmeter. Okay, suppose, concentrate. If I write average and average, these two devices are for DC operation. Okay, if I write RMS and RMS, RMS and RMS, we need to write this as which one? AC supply. But here, $1,000,000 question, sir. If we give DC, how the inductance and all will be there? Actually, conceptually we are taking, and that too. People are thinking that so DC means L will be directly short circuit. No, yeah, L will be acting as a short circuit only under steady state condition. Yes or no? That's why if you're talking about DC, transient period based concept is been taken. Therefore, I average right, but after some discussion that will be there in the tomorrow's class. Don't worry, that will be there in the tomorrow's class. I'll be concluding that MI instrument is not preferred for DC supplies. It is applicable, but not preferred for DC supplies. Why means so many errors are there. Among those, this energy related error also one point. So that's why I will conclude. That's why I'm saying that whatever I have spoken, whatever I have written, if any doubt is there, ask from that only. Whatever will be taken, whatever was not taken so far, don't worry, that will be there. If I say that all the instruments are completed, then by the time everything will be clarified. That's why I want to inject the things step by step only. That's what I'm not adding average RMS right now. Simply DC average, AC RMS over. Okay, sir. Equivalent circuit. Equivalent circuit. Sir, what is equivalent circuit? What is the equivalent circuit? Sir, in this, L will be playing the role. So therefore, we should take coil, pointer and all. What is that? Spring, pointer, spindle, everything, right? And coil, I'll be showing outside like this, just for clarity purpose. But I'm keeping the box now. This is complete box called as MI instrument. Okay, this is RM, meter coil inductance. LM, meter coil resistance and meter coil inductance. Clear? Right. So after this, one more representation. This is the textbook. This is I follow generally to have the coil picture clearly. But in the textbook, it will be shown like this. This is RM and LM inbuilt. RM and LM inbuilt. Both are one and only same. I am showing outside, but it inbuilt. But this box is MI. This box is MI. Clear? Right. So concentrate. Now I'm taking same concept like extension of range of MI instrument. That's why I spent lot of time in the extension of range of PMMC instrument, ammeter and voltmeter. If that is clear, here also similar topic only. But I will give the total explanation again, total questions and answers, everything what I asked, what I answered, everything will be taken again. If you answer this from onwards, wherever we are getting the extension, concept is same. Concept is same. Now let me take. What is the first one? Ammeter. Same concept and same procedure also. Same concept, same procedure. Sir, here. This is MI instrument, pointer, spindle, spring, bearings and all, everything. And here R and L only I'm taking like this. This is RM, this is LM, and this is, what is it? Moving iron instrument. Right? Okay. This value, suppose this value is 0 to 2 ampere, for example. Same concept, 0 to 2 ampere. But sir, I have 0 to 20. People are thinking that, sir, you're increasing only 10 times. Explanation purpose, simple number I'm taking. You can extend up to 22, 23, 15, 16, 23.5. Any number according to your requirement. Okay, according to our requirement only, we have to take like this. Okay, so this is I. Okay, but same thing, sir, large current we cannot allow. So therefore, simply division. What is this? This is IM. This is ISH. Okay, sir, it is AC structure, no? Yeah. Yes, simply R and L I'm placing over here. This is RSH, LSH, RSH and LSH. Clear? Okay, sir. Here, same condition, sir. Impedance we should say. There we have taken the terminology as resistance. Here we have to take impedance. Sir, why? Means that is only for DC. This is also for AC. So therefore, we have to take impedance notation. Therefore, ZSH is far less than ZM. ZSH is far less than ZM. Okay. Now, sir, whatever the derivation we have taken so far, same derivation. There one element, here two elements, but everything will be same only. So that's why what we can write now, sir. Similarly, what we can write, guys, ZSH is equal to Zm by M minus 1. No need to take the same derivation again, because same thing, their resistance, here impedance, their resistance, and here impedance. What is that? ZSH means RSH plus J omega LSH. Their inductance was not there. Oh, that's it. That's why complete mathematics I have taken step by step in the PMMC instrument structure. So therefore, similarly, we can write this entire ZSH value as Zm by M minus 1. Okay. Now, concentrate, guys. Concentrate. Sir, this MI is AC operated device also. Isn't it? It is operated on AC also. Therefore, my question here is, sir, if the AC supply is given, due to any supply variations, suppose frequency is varied, for example, due to some reason, supply frequency is varied. Sir, supply frequency, if the supply frequency is varied, due to that, XL will be varied. As you know, based on that, what is it here? frequency related error will be there. Definitely AC device itself indicates frequency error will be there. Listen, now our second duty, not only extension is over, topic is over, but I'm adding one more topic. What is that? Sir, as it is the AC operated device, the frequency errors are common in this instrument. Now, how do we eliminate? How do we minimize, or how do we eliminate those frequency errors? So that's why I'm taking the heading here, elimination of frequency error. Elimination of frequency error. Okay, concentrate. No one has asked this doubt, but this is general question I need to explain. Even though you are asking or not asking, this is what very important. Sir, people are asking that, sir, instead of this, if I keep only RSH, can't we have extension? We have extension. Why? Means extension purpose is, extension meaning is, what is it? Current must be divided. This current must be according to this capacity. Means IM should not be more than 2. Means large current must be bypassed. In order to bypass the large current, you can keep any element. Even if you're keeping only RSH, sufficient, because RSH value is very less than this total ZM, means it carries as high as possible current. Therefore, RSH is sufficient, right? But sir, why are you using LSH also? We are using LSH also means for this purpose, means with single shot, with single parameter, 2 shots will be there. Correspondingly, 2 things will be happening here. That's why I'm repeating the statement. Concentrate. Sir, extension means large current must be bypassed. So large current must be bypassed means only RSH is sufficient if you want to keep. But why we are keeping LSH means actually this is AC device, enough. But why we are keeping LSH means 2 reasons. Sir, total AC supply is there. So in the way AC element is to be there, LSH, that is common statement. But strictly speaking, what is the actual statement? Means I want to eliminate the frequency error. If I want to eliminate the frequency error, I need to add one frequency related element. If I want to eliminate the frequency error, I need to add frequency related element. With this element only, I am eliminating corresponding frequency. How? I'll show this. Concentrate. Elimination of frequency error. So how is it possible? Check it. Sir, VM by VSH. VM by VSH. What we can write? I into Z notation. VM by VSH. IS into ZSH and IM into, what is that? This. But VM by VS, both are same or different? Parallel, both are same. So that's why I'm writing like this. Simply here. ISH ZSH is equal to IM into ZM. Okay. Now I'm writing, sir, IM by ISH is equal to ZSH by ZM. Sir, what is ZSH? RSH plus J omega LSH by REM plus J omega LM. REM plus J omega LM. Okay. Now I'm taking RSH common here. What is that? ISH by IM is equal to. I'm taking RSH as common. If I take RSH as common, 1 plus J omega L by R. 1 plus J omega LSH by RSH. In the same way, REM 1 plus J omega LM by RM. Clear? Okay. Sir, if we are able to cancel these two, if we are able to cancel these two, what we can say, right? That entire ratio, the entire ratio will be I by I is equal to R by R. I by I is equal to R by R. So therefore, what I'm writing now, simply I by I is equal to R by R means frequency terminology itself is not there. So effect of frequency is eliminated. But people are asking that, sir, which will produce the frequency error? AC element is there means if any frequency changes are happening, that will be affecting the corresponding circuit operation, that is called as frequency error. AC supply is there means frequency errors will be there, because due to some reasons frequency may be varied. As the frequency varied, XL will be varied. As XL is varied, corresponding current and voltage drop will be varied, error will be occurred. That's why we are eliminating that. So that's why here, if I'm writing, if 1 plus j omega LSH by RSH is equal to 1 plus j omega Lm by Rm. If these two are equal, means, sir, 1, 1, j omega cancel. So what should be the equation here? LSH by RSH is equal to Lm by Rm. So what is LSH by RSH? Lm by R means, what is that? Time constant of shunt branch must be equal to time constant of meter branch. Okay. Now the question here, sir, let us go back. Sir, I'm not keeping this. I'm not keeping this. If I'm not keeping, LSH will not be there. Right? If LSH is not there, can we say this entire thing, this entire will be same, etc.? No. That is the reason why. That is the reason why. In order to eliminate the frequency error, definitely. In order to eliminate the frequency error, definitely. Yes. One second. Yeah, correct. Right. So in order to eliminate the corresponding frequency error, definitely frequency element must be added. Yeah, that's why we have added. Yes, IM by only. Right? Definitely this must be added. Therefore, in this extension topic, 2 points at a time. Not only extension, but also elimination of frequency error. How? Means ZSH is far less than ZM. Our condition extension will be solved. This is the formula already we have taken. In the same way, if you follow this condition also, we can go for frequency error elimination also. That's what the corresponding total procedure. Clear? Right? Okay. In the same way, if we are going for voltmeter, ammeter I have taken. No, here ammeter we have taken. Now, second one, voltmeter. As already we have taken concentrator. As already we have taken. Right? I can give the formula directly, but this extension topic is very important. That's why I'm repeatedly saying this. Those who understood, repetition. Those who have any small confusion, if you miss something, etc., it will be giving the clarification. That's what the point. Now, sir, voltmeter. Sir, voltmeter is there. Right? Here, RM, LM. This is our device. This is our device. Which device? MI device. What is its range? Let me take 0 to 5 volt. Something I'm taking 0 to 5 volt. 0 to 5 volt I'm taking. Okay, right, sir. But my requirement is 0 to some 50 volt, some voltage. Don't worry, some voltage, 0 to 50 volt. Right? Okay, sir. According to our requirement, we need to keep the element. But sir, voltage division should take place. Voltage division means automatically which element here? Series element. This is RSE. Okay, same concept. Sir, this is VM, this is VSE. Right, sir. Which should be more? RSE should be more. But be clear. Sir, if I keep RSE, thing will be done, no problem. But sir, if I keep the RSE, extension will be done. But what is there? Sir, frequency related element is there. as the frequency related element is there, frequency error will be there. How do we eliminate? That's why don't get confused. Frequency error elimination. Frequency error elimination. That's what the process, sir. In order to eliminate the frequency error of this one, for example, I need to add one more frequency element compulsory. That is the reason why here not only R, which should be there. I am saying everyone, this is completely basic fundamental topic. Definitely many doubts will be there if you don't listen. That's why concentrate. Different explanations are there. Concentrate, sir. Which elements must be means? Do we need to keep RL series or RL parallel, RC series or RC parallel? Which is to be preferred? I'm not asking the question. I will explain. Which must be preferred? RL series, RL parallel, RC parallel, or RC series, like that. Navya, why you have not taken LSC, sir? What is LSC? That's what I'm saying. RSC alone I'm not taking. Why not R? Why not? R means simply if R we are taking, that is what which one here correspondingly. What is that? It will not be nullifying the corresponding frequency. That's what I'm coming to that only. RL we have to prefer. That is RL series or RL parallel or RC series or RC parallel. But people are having one doubt. Sir, why R combination? Why R combination? Why not L? Do you have pure inductance practically? No. So that's why, right? If I'm saying that RL means it is practical inductor only. That's why be clear with the electrical basic terminology. If I say only capacitor, pure capacitance. If I say only inductance, pure inductance, is it possible? Definitely no. That is the reason why we need to concentrate on what is the practical element, practical inductor, RL series or RL parallel, RC series or RC parallel. That's what the point. Okay, let me take one by one. If you type, it will not be clear. I'm openly saying that if you type the message, it will not be clear. Concentrate. I did not ask the question. Kindly, I'm keep on saying the same statement. Kindly concentrate. Sir, if I keep R and L, okay, RSC, LSC, this impedance is ZSE is far greater than ZM, and similarly, what is it? ZSE is equal to Zm into M minus 1. That is common formula. Okay, but sir, inductance and inductance both are coming in series. What will be the problem? If both are coming in series, effective inductance will be increased. If effective inductance is increased, the circuit becomes more of lagging. More lagging is drawback or advantage. More and more lagging is always a drawback only. More and more lagging is always, because circuit should not have much more lagging. Okay, proper lagging, okay, 0.8 lagging, okay, but 0.5 lagging, 0.3 lagging, that's not accept. That's why if you're keeping RL series, no problem for the extension, okay, but the circuit becomes more lagging. More lagging circuit means the power factor will be poor, therefore correspondingly losses will be more. That's why RL series is not preferred. Okay, right. RL series I'm eliminating. Okay, sir, if I take RL parallel, so even though RL is parallel, this L and this L coming in series only. Effectively, finally, RL parallel again coming in series with the L only. Therefore, what we can see here, still automatically, what is it here? RL combination itself is not preferred. Therefore, L and L coming in series. Therefore, RL is not preferred. Okay, immediately people are asking the question, sir, if RL is not preferred like this, why did you take RL here? Because here L and L coming in parallel. Effective inductance is reduced. Effective lagging will be reduced. Circuit power factor will be good. So therefore, it is a directly advantage. No problem. Directly advantage, no problem at all. That's why generally we prefer RL in this ammeter. But in this voltmeter, we are connecting series. No, not used. Okay. Now which is left over? RL combination not preferred, either series or parallel. Now RC series. RC series. Sir, this is RESC and this is C. Okay. Sir, RESCC combination impedance is ZSC, far greater than ZM, and formula of ZSC same. Okay. Yes, our extension process is done. Extension process is done. Okay. But one drawback is there. Now I'm asking the question. One drawback is there. What is that? Of course, C will nullify the L. That is okay. That will be no problem. But one problem is one drawback is there. What is that? One drawback is there. What is that? Right. Okay. Many people, many people, yes, give the correct answer. Right. Many people see if RC series is being taken, right? Now the current will be flowing like this through this entire branch. Okay. Two problems I'm showing. Suppose if we give DC under steady state operation, if we give DC under steady state operation, capacitor acts as open circuit. If the capacitor acts as open circuit, it means no current is flowing. It means MI is not applicable for DC. No, it should be applicable for DC. Drawbacks may be more, but it should be applicable for DC first. Yes or no? But it is open circuit means current itself is not flowing. Therefore, DC, it is not working properly. Okay. So what about AC? What about AC? AC, it will not be shorted. It will not be open. No problem at all. But sir, if you give AC, suppose under resonance condition, what is it here? See, if I take RC series like this, RLC, perfect series circuit. RLC is perfect series circuit. So no, this is not parallel derived into series, etc. No, perfectly series. RL perfectly series with this means this is perfect RLC series circuit. Perfect RLC series circuit. Clear? As this is perfectly RLC series circuit, if resonance occurs, we don't say resonance will occur. When the resonance occurs, XL is equal to XC because RLC series circuit, XL is equal to XC. If XL is equal to XC, what is it here? Under series resonance condition, current will be maximum. Kindly I'm requesting, sir, why it is maximum? Kindly don't worry. That you study in the network theory. Resonance almost 2 to 2.5 hours topic separately on resonance. From that entire basic, I'm taking here. Few people network theory completed, but few people network theory not completed. Don't worry, that will be studied. That's why take this point as a note. That will be clearly 2 to 2.5 hours topic only on resonance is there. Don't worry. Don't worry, sir. If XL equal to XC, that is resonance condition, we say under series resonance condition, current drawn by the circuit will be maximum. So therefore, the current drawn will be increased like anything. Under which condition? Resonance. Sir, this increased current, yes, damages the device. Sir, why? This instrument has its own current, limit. But due to this entire resonance condition, yes, the current drawn by the circuit will be increased to very high value. Therefore, that high current damages the corresponding MI instrument. Therefore, if MI instrument is damaged, where is the question of extension of range? In order to have the extension of range of the meter, ammeter must be available. Voltmeter must be available there. Means meter must be available. If meter itself is not there, to which instrument you extend the range? That's why we don't use RC series also. We don't use RC series also. Finally, what is the ultimate thing available here? RC parallel. This is RESC and this is C. Because two resistors are there, no, I'm indicating like this. Sir, still, this impedance is very high than the ZM. Then extension will be happened normally. Now, let's verify the conditions again. Sir, DC is given. Capacitor acts as open circuit. If the capacitor is acting as open circuit, no problem for the instrument operation because yes, path is there. Therefore, for DC, even in the steady state condition, no problem. Okay, right, sir. Suppose I'm taking AC, sir. AC, if you are giving like this, don't we get resonance condition? We get resonance condition, but this is not perfect RLC series circuit. Why? RC parallel combination is in series with this. That's why finally this entire thing is coming in series only. But RLC directly not in parallel. Sorry, directly not in series. That's why even though resonance occurs, that is not called as a perfect series resonance. If it is not the perfect series resonance, it is not the pure series resonance condition, current will not be maximum. If the current is not maximum, normal current only flowing, therefore automatically, what is it here? There is no damage in the corresponding structure at all. That is the reason why we are going to use which one here? RC parallel circuit finally. Okay. People are asking one more thing. Sir, why only RC parallel? Why not LC parallel? That's what I told you. LC parallel means you need to take the pure inductance. You need to take the pure capacitance. Is it possible? No. RC parallel means it is a practical capacitor. In its last component is R. That's why practically called as RC parallel. So finally, which is acceptable here? RC parallel circuit. DC, no problem. AC, even though resonance occurs, current will not be drastically high because it is not the perfect series resonance condition. It is almost equal to parallel combination. We say, but neither perfect parallel nor perfect series. Therefore, current will not be maximum. Therefore, the maximum current will not be drawn. Instrument will not be damaged. That's why finally, what is to be preferred means RC parallel. Clear? Actually, this is the common process. Coil is generally used. It is satisfied directly. Here, coil is used generally, not satisfied. RC series, not satisfied. RC parallel finally satisfied. Okay, now, sir, if I don't use this one, what will happen? Right? Extension done. No problem. Why? RSC is far greater than ZM. Extension will be done. But, sir, if C is not there, this frequency error will be there, will be continued, cannot be eliminated, cannot be minimized. That's why this omega will cancel this omega, just like in the earlier discussion. This and this will be cancelled. No, in the same way, we need to keep what is a frequency related element to eliminate the frequency error. Suppose people are asking that, sir, I don't want to eliminate the frequency error. No problem. No need to use this. But concept says always frequency error is there. Yes, definitely. We need to remove. We need to try to eliminate. We need to try to reduce the corresponding error. Clear? Okay, right. Now, mathematics. This is completely conventional question. Explain the frequency error elimination method. Method. In the MI voltmeter, in detail 12 marks question. In detail 12 marks question, the ESC conventional. The ESC conventional 12 marks question will be there. Okay, now simple mathematics is simple math. Here Z total is equal to ZM plus ZSE. What is ZM? What is ZM? ZM is RM plus J omega LM plus ZSE. RC parallel will be getting RSE by 1 plus J omega RSC into C. This is the impedance of RC parallel combination. Now take this LCM etc. Simplify and try to eliminate the omega. That mathematics not required for gate or ESC object point of not required. Even though conventional class is there for ESC people, I will give the time for of 2 to 3 minutes. You need to simplify in the class. This is simple mathematics. There is no technical logic. And if you simplify that, finally you are going to get C is equal to 0.41 LM by RSC square. Means what is that here? If you are choosing the C value, equal to this one, what is that? Frequency error will be eliminated. Along with that, with this condition, with this formula, we can say that extension is also happened. Therefore, in the MI instruments, either ammeter or voltmeter, what is it? Not only extension but also frequency error elimination. Actually, writing purpose, theoretical purpose, frequency error is eliminated, we say, but practically what we say, frequency error is minimized, we can say, but conceptually frequency error eliminated. But now very important question, popular question is, popular question is, sir, why we have taken frequency error elimination only in MI? Why not in PMMC? Come on here, PMMC itself is only for DC. DC means frequency problem itself is not there. If the frequency problem itself is not there, why do we think, see, frequency error is not there, but I am trying to make that as 0. Or come on here, frequency error itself is not there. So therefore, automatically, yes, the thing will be done. What is it? PMMC, there is no question of which one? Frequency error elimination, because frequency terminology itself is not there. Where is the question of elimination? So that is what the total discussion related to. What is that? PMMC, construction, operation and everything. MI also construction, operation and everything we have taken. Clear? But now, sir, all I told you, this branch should not disturb its own construction, operation, scale and all. That's why I told you this will be connected externally. Here also, this will be connected externally. Same thing, PMMC also, the extension element is connected externally only. Yes or no? Therefore, whatever the element, that is extension of the element, extension element, that is shunt branch or series branch, should be made up of which material? Means here, this behavior should not disturb this one. This behavior is only to extend or elimination of frequency, but this behavior is not to disturb the corresponding instrument at all. That's why very important note here is, sir, shunts means RSH we say, or RSH LSH we say, no problem, but writing purpose I'm writing like this. And this is a technical word here, multiplier, nothing but series resistance. But no one should ask this question. RSH means this is PMMC. MI means RSH and LSH combination. RSC means PMMC. MI means RSC parallel with C. That implies no need to worry. Okay. Are made up of dash. Sir, suppose one thing is, sir, if I make this entire element, suppose resistance I'm talking, okay, this is made up of a positive temperature quotient of resistance material or negative temperature quotient of resistance material. What happens, sir? As the supply is continued, temperature will develop. As the temperature is increased, this RSC may be increased or may be decreased due to positive or negative temperature quotient of resistance. If this RSC gets increased or decreased, this will be affecting this circuit operation. That's why RSC and C must be fixed after designing. Clear? Same thing here also. Sir, if this value is keep on getting changed as the temperature increase or as the temperature is decreased, this behavior definitely affects the corresponding meter. That's why these elements should be made up of zero coefficient of resistance. But zero is possible practically? No, that's why made up of which one here? Constant temperature coefficient of resistance material. Constant temperature quotient of resistance material. Sir, what are those constant temperature quotient of materials? Materials such as manganese and constantan. Manganese or constantan, you can say. Manganese and constantan are having the constant temperature quotient of resistance. Constant temperature quotient of resistance. But this will be there in the material science, property of manganese, property of constant, etc. Based on the property of manganese, right? This is applicable only for DC operations. Sir, why? I'm saying no one should get the doubt, not required, because that is a property of material. The property of material, manganese itself is suitable for DC operations. Constantan is suitable for AC operations. So this is what the completeness. Suppose if you are using, if you are preparing, if you are making shunts and series elements, multipliers, with one constant temperature quotient like manganese or constantan, automatically these elements behavior will not disturb the instrument behavior at all. That's what the actual point. Clear? Okay, one more thing. Right, sir. One more note. A resistance made up of constant temperature coefficient of resistance material, right, called as swamping resistance. Called as swamping resistance. But indirectly, swamping resistance is made up of what is it here? Correspondingly, what is it? It is made up of constant temperature quotient of resistance material. That's why wherever you are getting swamping resistance word, yes, that is made up of which one here? Correspondingly constant temperature, that is either manganese or constantan. Yeah? So indirectly what we can say, swamping resistance is placed in the circuit to eliminate the temperature problem, or to eliminate the temperature errors, or to minimize the temperature errors and all. Right. Now people are getting one doubt. Sir, you told that RSH and RSM saying should not be varied, it is constant, but you told one more statement, sir, RSH must be according to our requirement, RSC must be according to our requirement. That's what you are missing. In my case, this is instrument 0 to 1, okay, 0 to 1 volt. Here RSC is there, my KC is 0 to 10. So RSC is equal to X. X means always X only in this experiment. Okay, suppose second device is there. Sir, 0 to 1 volt only I'm taking. Sir, I need to keep the resistance, but here 0 to 50 volt, 0 to 50 volt. What you have to keep? RES is equal to Y. In this experiment, Y means Y only. That is what the meaning. But don't think like, sir, you are changing. I am not changing this. Up to 10, what should be there? That is my requirement. Okay, and up to 50, what is this? That is your requirement. Therefore, for a given condition only, for a given condition only. That's why RSC and RSH are designed based on your requirement, that your requirement will be constant for a particular application. Constant for a particular application. Clear? Right? And already I told you one more point. Sir, MI is applicable for AC, but is it preferred for AC or not? I will tell you later. I told you. I will tell you later. I told you. If we give DC to the MI, what will happen? Do we prefer or not preferred? That will be taken later. No need to worry. So this is the total discussion. Step by step, construction, operation, mathematics, everything I have taken. Clear? Fine. Before going to the next topic, let me take some questions. Try this. Try this. Simple mathematics, simple mathematics. Few people give the correct answer. Right. See, very simple. Yeah. Here, theta is equal to half I square by Kc dl by d theta. Okay, half I square. What is the current? 5. So therefore 25 by Kc, 25 into 10 power minus 6 into dl by d theta. Constant 0. Here theta 3. One second. Sorry, it is a typing mistake. 1 second. This one. Theta square actually, not whole power, theta square. What is it? Theta by 2. But what people are missing is this one they are missing. That is into 10 power minus 6. Into 10 power minus 6. So automatically, what is that? Here, 25, 25, it will be cancelled. 3 by 2 minus theta by 4 is equal to theta. Simplify. Theta is equal to dash. What is that? You'll be getting 1.2. Anyway, radians only he has mentioned where theta is a deflection in radians. So answer is 1.2. Got it? For a given required value RSH or RSH, LSH, RSC or RSC parallel with capacitance will be fixed for a given required value. For a given required value, yes. Okay, fine. Let me take one more question. People are asking, sir, how we got 3 minus theta by 2? Kindly wake up. Don't sleep, wake up. dl by d theta. L is given here. Differentiate it. Differentiation of 10 is constant. Differentiation of 3 theta is 3. Minus theta square by 4 is theta by 2. N is also there, no sir. Where is N? Where the N is, where N is available? N is there in the PMMC formula, not in MI formula. Spring constant. Come on, yeah. 25 into 10 power minus 6 Newton meter per radian. Why Newton meter per radian? I told you in the corresponding spring control method also. Kc is equal to Tc by theta. Kc is equal to Tc by theta. Kc Newton meter. Theta radian, I told you. This is not tons here, Newton meter. It means you did not prepare the yesterday's class. Okay, very good. Right. Solve this. Try this. Come on. One student has given the 248 volt. What he is asking, what are you answering? See, what will be the value of capacitance to be used for shunting the series resistance to make the meter read correctly at 50 Hz? Means frequency errors are not there. C is equal to 0.41 Lm by RSC square. So 0.41 Lm. What is Lm? 1 Henry by series resistance, that is 2000 square. Right? 1000 square coming means microfarad. 0.41 by 2. What is it? 0.1025 microfarad. 102.5 kilo. What are you answering? 0.1 micro. Oh, correct. 0.1 micro is acceptable. 0.1025 is the actual answer. No problem. 0.1 acceptable. Right? So this is a total discussion about MI instrument. Don't worry, we are going to solve so many questions on PMMs and MI again. No problem. Now, I'm giving that. See, with this entire thing, there is no special advantage and special disadvantage, etc. But generally, that is connected. That is a designing stage only. That is designing stage only. Right. See, that's why I told you before asking, think once. One student gave that, sir, 0.41 by 4 equal to 0.205, sir. Who is this? Venkanna. Is it? That's it. Before asking, think once. Think. 0.41 by 4, 0.205. What is this here? If you don't know the mathematics, kindly use the calculator. Calculator is there, I think, with you. Kindly use it. See, if anyone, those who are on the line, if anyone is having the problem with calculations, you can use the calculator. No problem. That's what. Sir, sorry, sir, a mistake. See, don't say sorry. But before asking, think once. If this is the case, same problem will be repeated in the GATE exam. In the GATE exam, you will answer something. After coming to the home, checking the key, come on, small mistake, silly, wrong, silly mistake, wrong, silly mistake, wrong. If you are losing the mark, that should be having some weightage. Okay, it is very in-depth, confusing one. Losing the mark, acceptable. Silly mistakes, never, never. That's why be careful, be careful. Right? Okay. What I told you are very simple. See, before starting only I'm saying this. With this entire thing, no advantage, no drawback, nothing. But facility is there. That's why they are connecting. That's it. Nothing more than that at all. Be clear. Sir, PMMC coil is moving. Okay. Yes. What is it? Moving coil, nothing but coil is moving. MI means coil is fixed. Nothing but iron piece is moving. Okay, coil is moving, and here coil is fixed means iron piece is moving. Okay, right, sir. Here in the PMMC, yesterday structure you have taken. I have shown one video also. Right here, spring. One more spring like this. Okay, right, sir. Here, aluminum cylinder will be there like this. Aluminum cylinder. Okay, just for idea purpose, sir, coil is placed on the aluminum cylinder like this. Okay, two-dimensional picture, sir. Coil is on the aluminum cylinder, is on the spindle. Springs are also on the same spindle. So therefore, spring, that is spindle, and coil both are moving with same speed or different speed. Same speed only. Why? Everything is placed on the spindle only. That is the reason why. See, we can connect spring and coil like this. We can connect spring and coil like this. And we can give the supply. All I told you, there is no advantage, there is no drawback. It is only the normal connection possible. Is there possible? That's it. They're correct. That's it. No advantage, no other things at all. Leave it. Okay. But coming to the moving iron instrument, sir, this is the spindle, right? Here, one spring. Here, one spring. But coil is not on the spindle. Why? Spindle is movable, moving, but coil is fixed one. Coil is fixed one. Therefore, coil is some other place. All I told you now, coil will be like this. Sir, this is moving. This is fixed. Come on, guys. This is moving and this is fixed. So my question is, sir, can we connect? Can we connect like this? Can we connect or not? Never. Why? One is moving, one is fixed. If you're connecting like this, the corresponding connection will be damaged. That is the reason why. That is the reason why in this MI instrument, the supply will be given only to the coil. And here, the supply will be given to the coil and spring combination. Kindly don't have any doubt, any question. There is no any special advantage, etc. Nothing. Simply connection is there. That's it. That only I told you when I was taking the what is the spring control and what is the gravity control comparison. In the spring control advantages, some points I give, summary points, where in PMMC nothing but moving coil arrangement, spring carries the current, yes or no, and moving iron spring does not carry the current. That's it. Other than that, there is no other logic. Means, is it possible or not possible? Is it possible or not? Not possible. That's why they are not using. That's it. Nothing more than that at all. Clear? Right? Now, next one. MI instrument also advantages and drawbacks not completed. After completion of EMMC, I'll be taking all the three devices in detail. PMMC, MI, EMMC, all the three will be compared. After that, we are going to conclude like DC, which is preferred, AC, which is preferred, current voltage, which is preferred, power, which is preferred. Like that, all types of conclusions will be taken. No need to worry. Clear? Right? Now, next device is only introduction I'll give you. EMMC instrument. EMMC instrument. Sir, this is also called as electrodynamometer. Electrodynamometer instrument. This is a technical word. This is the common usage of electrodynamometer. But in your laboratory, electrodynamometer type only used. Okay. Clear? Right. Now, so therefore, electrodynamometer instrument. Sir, in this, how many coils and what is the deflecting torque and all I'm taking now. As usual, starting step is always same thing. What is that? Here. Sir, TD, TC, right? Damping torque. TD, TC, damping torque. Sir, TD. What is that in this? I told you in yesterday's class. I don't know you prepared or not. I don't know, but kindly concentrate. Sir, two coils will be used. Two coils. One is the fixed coil and one is the moving coil. Sir, Coil supplies again magnet. So one current carrying conductor placed in the other electromagnetic field experiences a mechanical force. Experiences a mechanical force. Yes, TD means movement is being started. Okay. Controlling, undoubtedly. Spring control. Okay. Damping. What is that? Air friction damping. That method only. Clear? Okay. Now, this is a terminology, but step by step, topic by topic, I'll be clarifying everything. See, first one, fixed coil. Right. There is no reason for that. This is the universal law we take. What is that? Fixed coil is connected in series. Fixed coil is connected in series. In general, this is a universal theory. Sir, why only in series? Why not parallel? Don't get anything. This is the standard constructed based theory. Okay. After that, moving coil. Moving coil. Moving coil is generally connected in parallel. Sir, so far, whatever the devices we have taken, right? In all those devices, either PMMC or MI, either PMMC or MI, only one coil. Here also, only one coil was there because PM permanent, moving coil one only. Moving iron piece is moving, magnet is electromagnet, one coil only there. Okay, but EMMC, the name itself is electromagnet moving coil. How many coils are there here? Two coils are there. How many? Two coils are there. So therefore, one coil is generally connected in series, other coil is generally connected in parallel. Sir, series connected coil is called as current coil or potential coil. Means series connected device means ammeter must be connected in series. So that's why here also coil is in series. Therefore, this terminology is current coil. Current coil. Okay, right. Sir, this coil is nothing but potential coil. Why, sir? Parallel device. A device which is to be connected in parallel for measurement of something is simply, what is it? Voltage, voltmeter. So far we have taken voltmeter, ammeter concept. Now we are taking potential coil, current coil. That's it. So far devices, now coils concept. That nothing more than that. Potential coil. It is also called as mechanical word pressure coil also. Potential coil or pressure coil will be there. Okay, sir. Ammeter must be designed with as high as possible resistance or as low as possible resistance. As high or as low means yes, current coil, low resistance. Okay, potential coil, high resistance. Why? Voltmeter concept, voltmeter, parallel connected device. Yes, potential coil, parallel connected structure. So therefore, what is it? Simply opposition, but resistance must be high. And fixed current coil means ammeter concept. Ammeter concept means automatically, yes, it should be having low resistance. Right? This is the complete concept. Okay, now, sir, with this, which parameters we are going to measure? Sir, here electromagnetism. Already in the MI instrument, I have given that in the electromagnet structure. In the MI instrument, I give that magnetism varies with the supply. As the magnetism is varying with the supply, applicable also for AC. Applicable also for AC. Isn't it? So that's why here also, what is it? Yes, DC as well as AC. DC as well as AC. But be clear, as usual, same thing. So DC average, AC RM, that is common. But not only this, it can be used for measurement of current, measurement of voltage, measurement of power. Three parameters are possible. Right? So far with PMMC or MI, which measurements was done? Either current or voltage only. But here, power is also possible. Here, power is also possible. So therefore, my question is, in this, power is not possible. In this, power is not possible. EMMC, power is possible. How? Now I'm asking the question, kindly respond. How the power measurement is possible in this? Come on. Come on. Yes. Very simple. Very simple. Yes. Many people give the answer. Right. Very good. Very good. Very good. Very good. Yes. Very nice. Simple logic. Sir, it has two coils. If it has two coils, one can be in series, one can be in parallel at a time possible. But here, only one coil. If you are connecting this in series, it acts as ammeter. If it is connected in parallel, it acts as voltmeter, but not both at a time. Here also, one coil, only one coil. So therefore, either in series or in parallel, not both. But here, both are possible at a time. Both are possible. That's why EMMC, that is what dynamometer power measurement is possible. But how? Construction, operation, everything will be taken, no need to worry. But only introduction only, I asked the question, why it is possible? Right, kindly you said correct only, but small change. So people are saying that, sir, due to potential and current coil. Okay, but actually that we should not say like that. Due to two coils, one coil connected in series, one coil connected in parallel, so power is possible. But mi, only one coil, either in series or in parallel, either current or voltage, not both. PMMs also not both, but here current and voltage both at a time. That is the reason why, yes, we can get the power measurement also. We can have the power measurement also. Clear? This is the total introduction regarding measurement. What is that? EMMC instrument. But construction is there, and with that construction, power measurement, voltage measurement, current measurement, everything I'm going to take in the tomorrow's class. Plus, after that, corresponding questions and corresponding comparisons of PMMC, MI, and EMC, everything will be taken. No need to worry. Clear? Okay, I'm stopping now. Let us have the doubt session. Come on. What is the frequency, error, and effect of it? If frequency is changed, XL is equal to 2 pi FL. FL is changed. XL is changed. If XL is changed, drop gets changed. If the drop gets changed, this is, what is that? Instrument. As the drop is getting changed, current will be varied. This current may damage the instrument. In a question itself, his answer is there. What is the problem with frequency error? What is that? Error. The word itself is error. Yes. Reading may be the problem. Instrument may be damaged or giving the wrong readings and all. One student told that, sir, 16F, we measure I average, but unit is in volt. Where? 16, I average. Unit is not in Where I have kept? Okay, okay, okay. This is okay. I thought it is. Yeah, yeah. No problem. V average. He has given V. He has given V. Yes, that's not written. Okay, thank you. Right. All the coils are made up of. All the coils are made up of copper material only, either winding or coil in the PMMC or in MI or in EMMC. The best conductor we can bear here is copper material. Okay. MI instrument coil is made up of copper. That is always the best. But once we are going for extension, manganese for DC and constantan for AC. Okay. So same question, sir. 15F time in millisecond. So what? Here 20 millisecond. Here 10 milli, 2 milli, 8 milli. Milli will be cancelled. Only value will be there. No problem. Right. I didn't get 0.41. How will you take? I told you to derive that. I told you to derive that. Kindly, after going home, derive this. Simply here, you derive this. Take this entire LCM and simply bring it. Try to cancel the omega on both the sides. You will get this. That's why I told you. Dot. Simply mathematical logic. I have not taken unnecessary mathematics. Only mathematics. Simply multiply again, again, and again. Multiply. You will get that. Right. That's what I told you. Yes. Right. Right. So voltage should be kilovolts, no, sir. Where I don't understand before answering. See, Vishnu, here magnitude, base, volt, time, 10 millisecond. Here, 2 millisecond, 5 volt, 8 millisecond, 5 volt. Okay, millisecond, 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 20 millisecond cancel, volt, 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 volt will be there. That's why before asking, kindly think once, think once. Right. Sir, one general note, how carry all the information, sir? Very good question. Simply, right? Day-to-day preparation. If the class is done today or tomorrow, right? Within a day gap, definitely you have to revise that. Definitely you have to revise that. Otherwise, definitely you will forget the things. That's why if the class is done today, if today or tomorrow, if you are reversing, if you are revising before coming to the next class, the things will be done. But definitely you can remember. And that too, after completion of measurements, for example, other subject will be done. Okay. Meanwhile, at least day 1, 2, 3 hours, etc. Measurement should be revised. After second subject, third subject, no, two subjects like that. Continuation revision should be required definitely. Right. Vaishnavi, sir, we are going for extension of meter, sir. Then what is the use of large range? If the large range device is not there with you, as the operator, can you do it or not? That too, that is possible when corresponding RSS should be available with you. RSS should be available with you. RSC, so C should be available with you. That's why only this is mathematical concept, possible or not possible. But if the high range device is there, use it. But if the high range device is also not there, is it possible or not possible? That's on the point. Right. Sir, in energy stored calculation, do we need to neglect DI? Yeah, that's what I told you. By neglecting DI term, DI square term and all, I told you already, right? Correct. So in PMMC extension, of ammeter, if we use R in series, we need more resistance. One second. Yeah, this one, right. The doubt here is, Meghana, sir, in PMMC extension of ammeter, if you use R in series, why do you use R in series? If you are using R in series, if you use R in series, suppose here I have PMMC ammeter of 0 to 1 ampere. I am using RSC here. Sir, still, can I give 0 to 10 ampere? Meghana, can I give 0 to 10 ampere? No, yeah. This is 1. If everything is coming in series, 1, 1, 1 means it is up to 1 only. Where is the question of extension? That's why current division. That's why we are going for which one? RSH. Kindly have the basics of current division, voltage division, right? So did you see my question, or will the clarify later in the course? Which question? Bhavani, sir, in PM's extension for ammeter, practically can we take total I is equal to Im into multiplying factor? Is it? Here, I is equal to Im into what is this? Rm by RSH plus R1. How do you get M means? M means only Im. No, yeah, no, kindly follow the mathematics. Yes, Ramachandra Kashyap, correct. Bhavani, I total equal to Im into multiplying factor. That is, yeah, I total means I is equal to Im into, is it multiplying factor? Is it multiplying factor? Next, 28F. 28F, can you explain how change in inductance due to deflection happens? See, right. Sir, I is changed. Magnetization is changed, means stored energy means L will be changed. Then force will be changed. Then theta will be changed. Simple logic here. I is changed. More magnetization means more force. More force means the iron piece will be making more closer to iron piece is becoming more closer means reluctance is further low. L is equal to N square by reluctance. Reluctance is further low. L will be high. L is variable. Yes. Alan Matthew. Sir, in extension of range of Mi, okay, I'm going to that. In extension of range of Mi, we derived equation for ZSH and LSH. We are not derived the equation for ZSH and LSH. No, ZSH only we derived. ZSH only we derived. And we have derived the condition for frequency elimination. That condition we got it as, what is it? LSH by RSH equal to LM by RM. LM by RM. Right? See, can you try to understand? Try to understand. Sir, from this formula only we are going to get, no, why did you use two statements here? That's what your question, right? Yes or no? That is what this derivation I have not taken now. This derivation I have taken in the PMMC. No, as the derivation are there, I have taken everything. Without this entire thing, if I give this formula directly, you people only ask that, sir, how are you getting this? That's why I've taken this derivation again. That's it. Try to understand the terminology. Right. ZSC, right? Vamshi. Sir, 34F ZSC, sir. ZSC. Zm into M minus 1. All I told you, know, in the PMMC, RSC equal to RM into M minus 1. Similarly, ZS equal to Zm minus 1 as it is. Sir, see top of the page. What do you mean top of the page? Which one? Okay. If Bhavani, if it is coming like that, you can use it, no problem. If you're converting that resistance into current, if you are getting, yes, you can take it, no problem. Right. So in AC signal, RMS value is √2, then applied to PMMC. Practically, do you do that? Practically, do it. Mathematically, you can do anything, but practically, can you do that? But student is saying that here, sir, AC RMS signal multiplied with √2 and given to PMMC. Do you do practically, Usha? No, your thought is correct, but practically you cannot do. Mathematically you can do, right? RMS is multiplied with √2. It becomes maximum, not average. You want to convert RMS value into average value given to PMMC, no problem. But practically we cannot do that. Mathematically we can do, no problem. Mathematically we can do. That too not √2. That is by pi notation, right? Due to capacitor time constant to be considered, sir. Question is incomplete. Okay. Right. Today, first problem. Which one? Yeah, in this one. Pawan Kumar, is it you're asking? Pawan Kumar. Right. See, IFSD equal to 1 by S. 1 by 1000 is equal to 1 milli. Right. Right. Sai Charan Reddy. Sai Charan Reddy. Right. Good question. Sir, instrument is 0 to 1. 100 divisions are there. Right. Sir, if you increase for 100 volt, if you are increasing for 100 amperes, how the scale? Come on here, I already told you, you are missing something. You are not changing the scale and all. You are adding the resistance parallelly, RSH, and the two 0 to 10. You are not observing from the device. 0 to 1 only you are observing. 0 to 10 you are calculating. That's what I told you. What is it? Scale, construction, divisions, we are not changing. We are not changing. We are externally connecting. After it is showing 0.5, 0.4, 0.3, 0.6, any number, by utilizing the mathematical equation, we are calculating this. So many times I told you, I'm repeating this. Construction operate, what is it? Construction and scale divisions are not changed. There is no problem with resolution at all. Due to capacitor effect of time constant to be considered in MI as voltmeter, sir. In MI voltmeter, why the capacitor is used? I explained four or 5 times of explanation, right? Kindly go and watch the video again, no problem. Right. See, I did not say that 0 to 1 device is there. Sir, why are you extending 0 to 10? Why you are not going for 0 to, I did not say don't go for it. I did not say don't go for it. I said, if this device is not there with you, can you go for extension or not? Yes, we can go for extension. That is what the question. Right.
Good evening, sir.
Yeah, good evening.
Yes, sir. Sir, my doubt is from second class. So actually, sir, due to some health issues, I visited doctor that day.
Okay, okay.
saw.
Now are you okay now?
Yes, sir. Now I'm fine.
Okay,
Recovering, still recovering.
okay,
Thank
okay. Take care. Take care. Tell me.
Sir, in that day, last question you did, sir. The power in a 353 wire load is measured using 200 watt full scale watt coils.
No. Little bit louder, please. Voice is not clear.
Sir, there you use the term accuracy class.
Yeah.
So, sir, I'm not getting what is accuracy classes.
I give the terminology. Have you gone through my videos?
So, not videos, not that wasn't there
No.
wasn't
As
time.
you miss the classes, have you gone through the class videos again?
So, class notes, I grew through class notes, sir, one time.
Actually, in the class notes, the terminology sheet missed. Actually, some paper file corrupted. That sheet missed. Kindly watch that video. On that video, I explained already. Accuracy class means this implies guaranteed accuracy error.
Okay, sir, now it's fine. Now got
That's
it.
all. No problem. No problem. Accuracy class means guaranteed accuracy error. In that power problem, plus or minus 1%, plus or minus 0.5% is given. These two are taken as guaranteed accuracy errors. No need to worry. You can go to that video again. But first, take care of your health first. Spend 1 or 2 days on your health. After that, concentrate on the subject.
No, sir, no
Ashish,
problem.
and you have my number. No, you can talk to me later.
I
No
got it,
problem.
no problem.
Anytime.
Okay, sir.
Okay.
Thank you, sir.
Hello, Naveen.
Sir,
Yeah.
sir, you told that PMMC read once you can open that page now, sir.
PMMC.
The problem down, sir. PMMC is I average is equals to -8. That problem.
Okay. Yeah.
Yes, sir. సార్ ఫస్ట్ దాంట్లోనేమో మీరు 0 నుంచి ఫుల్ స్కేల్ వరకు రీడ్స్ అవుతుంది -8 టైమ్స్ అనేది 0 అనేది ఇండికేట్ అవుతుంది ఎందుకంటే మైనస్ దగ్గరికి పోదు కాబట్టి అని చెప్పారు కదా సార్. సెంటర్ 0 పిఎంఎంసీ ఏమో ఐ యావరేజ్ ఈక్వల్స్ టు -8 అంటే మళ్ళీ నెగిటివ్ ఫుల్ స్కేల్ తీసుకున్నారు కదా సార్ ఇక్కడ. మరి అది పిఎంఎంసీలో కూడా తీసుకోవచ్చు కదా సార్.
పిఎంఎంసీ అంటేనే పిఎంఎంసీ ఇన్స్ట్రుమెంట్ అంటేనే 0 to ఫుల్ స్కేల్ అంటే వీటన్నిటి ఏమంటారంటే డిఫ్లెక్షన్ టైప్ ఆఫ్ ఇన్స్ట్రుమెంట్స్ అంటారు. దీన్ని ఏమంటారంటే నల్ టైప్ ఇన్స్ట్రుమెంట్. అది మీకు గ్యాల్వనోమీటర్ టాపిక్ చెప్తాను. అందుకని పిఎంఎంసీ కానీ ఎంఐ కానీ ఈఎంఎంసీ కానీ ఇవన్నీ కూడా డిఫ్లెక్షన్ టైప్ ఆఫ్ డివైజెస్. ఇన్ దోస్ నెగటివ్ స్కేల్ ఈస్ నాట్ దేర్. నెగటివ్ స్కేల్ విల్ నాట్ బి దేర్. దీస్ ఆర్ ఓన్లీ ఫర్ మెజర్మెంట్ ఆఫ్ ద వాల్యూస్, మెజర్మెంట్ ఆఫ్ ద కరెస్పాండింగ్ వాల్యూస్. అందుకని ఇది 0 to ఫుల్ స్కేల్ ఉంటుంది, నెగటివ్ స్కేల్ ఉంటుంది. గుడ్ క్వశ్చన్. ఇదే స్కేల్ ఇక్కడ తీసుకోవచ్చు కదా అంటే ఇలాంటి స్కేల్ ఉన్నదాన్ని గ్యాల్వనోమీటర్ అంటారు. వన్ థింగ్. సెకండ్ థింగ్, సింపుల్ మీకు యాక్చువల్గా క్వశ్చన్ ని బట్టి నెగటివ్ కరెంట్ వస్తుంది. ప్రాక్టికల్ గా నెగటివ్ కరెంట్ ఉంటుందా?
అంటే సార్ నెగటివ్ గా కనెక్ట్ చేసినప్పుడు నెగటివ్ కనెక్టింగ్ ఉంటది కదా సార్.
నెగటివ్ కరెంట్ ప్రాక్టికల్ గా ఉంటుందా?
అంటే కనెక్షన్స్ వల్ల నెగటివ్ కనెక్షన్.
నేను అడిగేదాన్ని అది నెగటివ్ కరెంట్ ఉంటుందా ప్రాక్టికల్ గా?
ఐ డోంట్ నో సార్ ప్రాక్టికల్ గా అంటే.
ప్రాక్టికల్లీ నెగటివ్ కరెంట్ ఉండదండి. మీరు ఇక నిలబడి నా సైడ్ వచ్చే కరెంట్ పాజిటివ్ అనుకోండి, నేను నా నుంచి వెళ్ళే కరెంట్ ఏమవుతుంది?
నెగటివ్.
అది అంటే దాని మీనింగ్ ఏంటి? ప్రాక్టికల్ గా కరెంట్ కి మ్యాగ్నిట్యూడ్ మాత్రమే ఉంటుంది, నెగటివ్ అనేది డైరెక్షన్ మాత్రమే. అందుకని న్యూమరికల్ గా తీసుకునేటప్పుడు నెగటివ్ తీసుకొని కరెంట్ అనేది రివర్స్ డైరెక్షన్ లో ఫ్లో అయితే అది మీనింగ్. అందుకని మనం ఇన్స్ట్రుమెంట్స్ డిజైన్ చేసేటప్పుడు నెగటివ్ కరెంట్స్ కి రిఫరెన్స్ గా తీసుకొని చెయ్యం. ఎందుకంటే మ్యాగ్నిట్యూడే కదండి. మ్యాగ్నిట్యూడ్ ఏంటి? ఇప్పుడు మనకి నెగటివ్ కరెంట్ ఏంటి? నా సైడ్ రావాల్సిన కరెంట్ రివర్స్ లో వెళ్తుంది. అప్పుడు మీరు ఏం చేస్తారు? రివర్స్ చేసి ఇవ్వాలి టెర్మినల్స్. ఆటోమేటిక్ అది వాల్యూని చూపిస్తుంది. అందుకని ప్రాక్టికల్ గా నెగటివ్ కరెంట్, నెగటివ్ వోల్టేజ్, నెగటివ్ పవర్ ఉండదు. బట్ మ్యాథమెటికల్ గా వాట్ ఎవర్ వీఆర్ ఎక్స్పెక్టింగ్ వాట్ ఎవర్ ఈస్ దేర్ యాక్చువల్లీ రెండు గనక రివర్స్ లో ఉంటే రివర్స్ కరెంట్ అంటాము, అంటే నెగటివ్ కరెంట్ అంటాం. అంతే తప్పితే నెగటివ్ కరెంట్ ఉంది కాబట్టి దీన్ని ఇలా కూడా డిజైన్ చేయొచ్చు కదా అంటే యాక్చువల్ మనకు ప్రాక్టికల్ నెగటివ్ వాల్యూ అనేది ఉండదు. నెగటివ్ వాల్యూ అంటే ఏంటి మనకి సింపుల్ గా రైట్, రివర్స్ ఏదైతే ఉందో దానికి కాకుండా ఆపోజిట్ లో ఫ్లో అవుతుంది. ఆపోజిట్ లో ఫ్లో అవుతుంది తెలిసినప్పుడు ఏం చేస్తాం మనము, టర్మినల్స్ రివర్స్ చేసి ఇచ్చేస్తాం డైరెక్ట్ గా. అందుకని పాజిటివ్ వాల్యూ. అందుకని మెజర్మెంట్ ఎప్పుడు కూడా డిఫ్లెక్షన్ టైప్ ఇన్స్ట్రుమెంట్స్ ఎప్పుడు కూడా 0 to full scale వాల్యూకే డిజైన్ చేస్తాం. ఒకవేళ సార్ మనకి లెఫ్ట్ నుంచి రైటా, రైట్ నుంచి లెఫ్టా, ఏ డైరెక్షన్ లో కరెంట్ ఫ్లో అవుతుందో తెలీదు అని అనుకున్నప్పుడు ఇలాంటి డివైస్ యూజ్ చేస్తాము. అవి ఎక్కడ అంటే బ్రిడ్జెస్ లో యూజ్ చేస్తాము. ఆ బ్రిడ్జెస్ టాపిక్ తీసుకున్నప్పుడు ఈ డివైస్ ఇంపార్టెన్స్ అంటే చూపిస్తాను. ఒకటి. సెకండ్, ఇప్పుడు సర్క్యూట్ ఇలా ఉందండి, ఇది ఒక సర్క్యూట్. ఈ సర్క్యూట్ కి ఇలా కరెంట్ ఇస్తున్నాము అంటే ఏంటి, ఇక్కడ నుంచి పాజిటివ్ టెర్మినల్, ఇక్కడ నుంచి నెగిటివ్ టెర్మినల్ ఉంది కాబట్టి మనకు తెలుసు ఆల్రెడీ ఇక్కడ. అప్పుడు ఎలా కనెక్ట్ చేస్తాం మనము, ఓకే కరెంట్ డైరెక్షన్ తెలుసు, సో అమ్మీటర్ ఇక్కడ పాజిటివ్, ఇక్కడ నెగిటివ్ కనెక్ట్ చేస్తాం. ఆటోమేటిక్ గా పాజిటివ్. నెగిటివ్ కరెంట్ ఎక్కడ ఉంది మనకి, అందుకని దీంట్లో బిలో జీరో స్కేల్ అనేది మెజరింగ్ డివైస్ లో డిఫ్లెక్షన్ టైప్ ఆఫ్ డివైస్ లో ఉండదు. ఎక్కడైతే టాప్ టు బాటమ్, బాటమ్ టు టాప్, లెఫ్ట్ టు రైట్, రైట్ టు లెఫ్ట్ కరెంట్ ఎలా ఫ్లో అవుతుందో తెలియని సర్క్యూట్స్ లో, తెలియని కండిషన్ లో అప్పుడు ఇలాంటి డివైస్ యూజ్ చేయాలి. అది ఎలా అనేది తర్వాత చూస్తాం.
ఓకే సార్.
రైట్,
ఓకే
ఓకే
ఓకే.
Yeah, who is this? Yeah, Mubin.
Sir, Mohammed Mubin.
Yeah, tell me.
Sir, that vein occupies low reluctance position in MI instruments we have discussed now, sir.
Yeah.
Yeah. Please open the slides.
Yeah. Tell me.
Yes, sir.
Yes.
Sir, actually, how we are, sir, I have an idea about this. When two parallel conductors are carrying current, then the flux will be there. Then the conductor moves from that. I think you know that in networks, sir, basic networks.
Yeah.
The same principle here also, sir.
Same principle, but only the thing is here, not two coils, only one magnet, one is iron piece. Means one is a magnet, one is a magnetic material.
Okay.
Okay.
Sir, can we assume as low reluctance? Sir, in that we studied that the conductor moves from high flux lines to low flux lines. High flux means low reluctance, na sir. Low flux lines means high reluctance, na sir. But we have taken
moves from.
Sir, please draw two parallel lines.
That is which law? Whenever a current carrying conductor plays in the magnetic field, it experiences a mechanical force.
Yeah,
right?
yeah, not that, sir. Two parallel conductors carrying current in same or opposite direction.
One second. Two
not
parallel
coils, sir. Straight lines.
Huh?
Straight lines.
One line. Okay.
Yes, sir. Now current is flowing through that. Put arrow and I.
I1, I2.
I2. So now draw magnetic fields based on right hand rule.
Okay.
That one, sir. Yeah.
Like this.
I think
like
now
this, something. Okay.
Sir, now put arrows on that field, sir. Field.
Clockwise.
Field direction.
Clockwise. Yes.
Sir. Yes, sir. Sir, now we can see that in between the flux is opposing, right? I mean opposite direction between two conductors.
Yeah.
It means the flux is getting reduced.
Yeah.
So reduced now, sir. So what do they do? The right and left are having more fluxes now, sir. So those fluxes try to come in between. It means conductor gets attracted. I am thinking I studied that way, sir. So here also the same thing I am asking.
No. You're missing. See, between these two, more flux is there, less flux is there. That is one point. Okay. And that too, this principle is completely different from our principle. Because here, this is one coil. Okay, conductor coil, right? Flux is there like this. This is the flux. Here, iron piece is placed. Okay, right? Here, how much flux is there? Less. Here, how much flux is there?
Less.
More.
Little
Here,
bit.
how much flux? Come on, not like that, not like that. Here, between these two, come on guys, between
Ah.
these two, the air gap is fixed before
Fixed.
starting the operation.
Okay.
Okay, the moment operation is being started, supply is given, this iron piece will be getting attracted by the corresponding coil. Means the iron piece is moving towards the closure, to the corresponding coil. That is called as air gap between these two is reduced. As the air gap between these two is reduced, what is it? Flux linking will be more, nothing but simply reluctance will be less. That is not the point.
Okay, we have
Right?
to analyze in this way. Okay, sir.
The thing,
Yeah,
see,
okay.
we
No,
need to
no,
analyze
sir. Yes,
this.
I'm analyzing in that way, sir.
No, this is a completely different. No, yeah. This
Yeah,
is
yeah.
with respect to two coils concept. Two
Yeah.
coils means two magnetic fields are there. But in this, iron piece does not have its own magnetic field, right? Iron piece magnetic field depends on coil magnetism only. That's
Yes.
why one is source, one is sink here. But in
Yes.
your doubt, two are sources.
Sources. Yes,
Good.
yes.
Yes, that's what.
Yeah, sir. One more, sir.
Yeah.
Sir, that MI repulsion type instrument is there, na, sir?
Yeah.
Sir, that construction is not clear, sir. I mean, it's too.
Yeah, actually, visualization, simple logic. Here, I gave this is more clear. See, this is coil here. Circular
Yes.
shape of coil. Okay.
Yes.
Here to this coil only, iron piece is placed.
Okay.
Okay. At the center, from here to here, small iron piece is placed here. Okay. Now, between these two, which field will be there? Repulsion will be there.
Same.
Same field means repulsion. Therefore, it will move away from this one. Means the iron piece will become like this. Means moving away.
Sir, I have doubt on that fixed iron piece also, sir. Is it how much its length? Half of the circumference, 1/4, 1/3, like how much?
Very good question. Very good. That's why up to how much you need to keep here 0 to full scale value. Means if it is moving up to which point, then the pointer will reach to full scale. That depends on their construction. No need to worry. That's why it is moving means up to how much it has to move. Yes or no? Up to how much it has to move, based on that only 0 to full scale value will be taken. Suppose if I take half a circle, for example, half a circle, that too, where you are placing iron piece at the time of starting, it is coming over here. For example, repelled, means it is looking like attraction from other side also, right?
Yes.
That's what. But this entire thing from where to where means I told you, almost 120 degrees or something like this. Based on that, the iron piece sizes will be taken. That much construction not required.
Okay, sir. That explain that core also, sir. That winding, how we are placing the winding in that core.
Yeah, actually, it is generally very, very general question. See, this coil is placed such that internally one field, north field, outside south field. In that way, the coil is placed. That's why I told you, according to the designing, internal north pole. Okay, if the iron piece is placed cut by the north, one more iron piece is placed cut by. That's why I told you the construction, the instrument is designed such that two iron pieces are getting the same polarity, thereby repulsion takes place. That's what the point. Other than that, construction is generally, don't worry, because repulsion type construction visualization purpose is very, very, very difficult. That too, real-time experience only you will understand. That too, mostly we use attraction type only. Whatever the instrument you use in the laboratory, MI, all are attraction only. Unless and until we mention repulsion type, they don't give. No need to.
Sir, mostly attraction, sir. I analyze that repulsion is most widely used.
No, advantage is with repulsion. Advantage, that's what. If we want to go for the easy construction, so automatically attraction. If you want to go for the any type of construction, repulsion. See, industry, yes, repulsion only. Industry is repulsion only. But normally, if you want to analyze only for random experiments analysis, attraction type. Okay, as your answer, yes, repulsion type is mostly what is used in the industrial purpose, etc. Because based on one more point I can say, compared to attraction force, repulsive force is strong, we can say generally. I don't know whether it is known or not. Based on the magnetic theory, we say. That's why repulsion type instruments are mostly applicable in the real-time world, but only for analysis point of view. Mostly attraction type only we prefer. Analysis point of view,
Yes.
not real-time.
Yes, sir. Sir, that statement is repulsion is sure test for magnetism, sir. Matlab, between attraction and repulsion, to know whether it is having magnetic property or not, we do repulsion test rather than attraction.
That's
That is a statement. Okay,
Yeah.
sir. Okay, sir.
So
One more. Sir.
repulsion is giving more information actually.
Yeah,
for-
yes,
yeah.
yes. That's why
Very
only
good,
I've
very
said repulsion, sir. Okay, sir. One more, sir. This in MI ammeter, sir.
Yeah.
Why can't we use capacitor, sir? I mean,
Actually, that's a good question. If RL is suitable, generally we don't go for capacitor, because practically, suppose if 100 elements are there, if 100 passive elements are there, 80 to 85 passive elements are inductive elements only. If you want to go for capacitor, special construction is required. That's why generally wherever RL is possible, we prefer coil preference only. Other than that, no other logic, no problem.
okay.
Only
Simple.
practical availability point of view. That's it.
Sir, that we in multipliers, MI
Yeah.
multipliers, C equal to 0.41 LM by RSC square is there, na, sir?
Yeah.
Sir, after solving all this, I got it. I firstly in semester only solved that C equal to LM by RSC square, but 0.41 we are not getting, sir. Why we are? I mean,
See, can you send the derivation if
yes,
it
sir.
is
I
possible?
can.
Yeah, you can send.
Now,
I'll talk.
I'm having with my notes only that.
Yeah, okay. You can take the photograph and you send me. I'll talk to WhatsApp. No problem. After that
Okay.
entire derivation, small values will be neglected. We'll be getting this. I'll discuss. No problem.
Sir?
Yes.
Thank you, sir.
ఇండక్టర్ అండ్ కెపాసిటర్ అనేది రెండు స్టోరేజ్ ఎలిమెంట్సే కదా సార్?
అవునమ్మా.
అప్పుడు మనము ఇండక్టర్ ప్లేస్ లో కెపాసిటర్ యూజ్ చేస్తే ఏమైతుంది సార్?
అదే అంటున్నాడు ఎక్కడ
అంటే ఇండక్టర్ అమ్మీటర్ లో అయినా వోల్ట్ మీటర్ లో అయినా కానీ ఇండక్టర్ ప్లేస్ లో కెపాసిటర్ యూజ్ చేస్తే ఏమవుతుంది సార్?
ఇక్కడ అదే అంటాడు, కెపాసిటర్ యూజ్ చేస్తే ప్రాబ్లం ఏం లేదు. కాకపోతే ఇండక్టర్ అనేది సూటబుల్ అయినప్పుడు మనం జనరల్ గా ఇప్పుడు ఆ అబ్బాయి అదే అడిగాడు ఏంటంటే, సరే ఇక్కడ ఆర్ఎల్ కాకుండా ఆర్సీ ఎందుకు యూజ్ చేయలేము అంటే, రైట్, ఆర్ఎల్ సూటబుల్ అయినప్పుడు ఆర్సీకి జనరల్ వెళ్ళాము. ఎందుకంటే ప్రాక్టికల్ గా మోస్ట్ ఆఫ్ ద ఎలిమెంట్స్ ఆర్ ఇండక్టివ్ ఎలిమెంట్స్ ఉంటాయి మన ప్రాక్టికల్ గా. ఎలక్ట్రికల్ పీపుల్ ఆల్సో జనరల్ చెప్తారు ఏంటంటే, లోడ్స్ ఎలాంటివి ఉంటాయి, లోడ్స్ మనకి బేసిక్ గా ఇండక్టివ్ లోడ్సే ఉంటాయి. కెపాసిటివ్ లోడ్స్ కావాలి అంటే స్పెషల్ కన్స్ట్రక్షన్ తీసుకోవాలి, లేదంటే సింక్రోనస్ మోటార్ ని ఓవర్ ఎగ్జైటెడ్ అండర్ ఎగ్జైటెడ్ లాగా యూజ్ చేయాలి. అందుకని ఆర్ఎల్ కనుక సూటబుల్ అయితే ఆర్సీకి వెళ్ళాల్సిన పని లేదు. అది ఒకటి లాజిక్, అంతే, వేరే టెక్నికల్ లాజిక్ ఏం ప్రాబ్లం లేదు.
సార్ ఐఎం బై ఐఎస్హెచ్ ఈజ్ ఈక్వల్స్ టు M-1 అనేది ఈక్వల్ అవుతుంది కదా సార్? ఇక్కడ కింద డెరివేషన్ ఆర్ఎస్హెచ్ ప్లస్ జే ఒమేగా ఎల్ఎస్హెచ్, అదే ఎట్లా వచ్చింది ఆ డెరివేషన్ సార్?
ఏది ఇదా? జెడ్ఎస్హెచ్ అంటే ఏంటమ్మా? ఆర్ ప్లస్ ఎల్ కదా. జెడ్ అంటే ఫార్ములా.
ఎస్ సార్, ఆర్ ప్లస్ జే.
ఆర్ ప్లస్ జే ఎక్స్ఎల్.
ఓకే.
ఆర్ ప్లస్ జే ఎక్స్ఎల్. ఎక్స్ఎల్ అంటే ఏంటమ్మా? ఒమేగా.
ఓకే.
ఓకేనా?
ఓకే సార్.
Right. Okay, I'm closing session. If any doubt is there, kindly let us talk tomorrow.
Sir, one last, sir.
Who is this?
Mubin, sir.
Yeah, tell me.
Sir, in MI we have only the torque equation and the theta equation, only those two, and that frequency error concept.
Yes.
Only three are important. I mean, brief summary.
Mathematically, yes.
Remaining all are on just theory points. And
Yeah. In PMMC also same thing. Torque equation, theta equation, and RSH, RSC. Same.
Yeah, same. Okay, sir.
Yes.
Thank you, sir.
Yes.
Sir, I've already sent it. Please check it. And
Yeah. I'll check it.
Thank
I'll
you.
talk to you. No problem.
Thank you, sir.
Yeah, it's right.
Hello.
Yeah.
Hello, sir. I am audible.
Yeah. Tell me.
Okay, sir, actually, I have doubt in relative error. Actually, in the first chapter, sir, in that chapter, sir, there are some equation like that division. Suppose in numerator there is some term like v divided by I. Sir, in that section, I did not getting that when we have to take addition and subtraction. Like in parallel resistance, sir, we take a subtraction of numerator
See,
resistor.
very good. Okay, okay. I got your doubt.
And sir, I have one another doubt in sir. In this also, in the 2009 question, sir, there is the one just a control system example given. In
Yeah,
that section, they take minus error or numerator error minus denominator error. Sir,
Hmm.
so how can we understand when we have to use the
See,
shortcut method?
yeah, see,
Okay, yes, yes, sir.
whatever the question, right? Only in parallel subtraction.
Okay,
Okay,
yes,
multiplication, division, addition, subtraction, everywhere addition of the errors only. But in that control system question, that depends on the control system. What is that? That is gain of the system. That is gain of the system means one to
yes,
one link will be there. One to one, what is that? Gain. One gain is given to other gain. Other gain is given to other gain. That you will come to know in the control system well. That actually their
yes.
minus only will be there. But that is not
Okay.
our measurement based question, but unknowingly some other booklets, etc., that is given in the measurement topic, right?
But
That's why.
sir, okay, sir, I got it. Okay, but sir, one in that question, sir, actually, the control section, sorry, control system perspective is that just we have to form equation from that question, sir. We can
Yes.
just form the equation like G1, G2 divided by G3.
G3.
In that perspective, sir, we see that after that it will be a measurement question, and based on
No.
that, sir, I can just form the equation is. Because sir, I just asked to the sir actually control system. They said that the equation will be G1 into G2 divided by G3. This
Yeah.
equation will be formed.
Yeah.
And sir, in that question, then it should be G1 G2 divided by G3. This equation is equal to output divided by input.
Yes.
Yes, this equation of the output divided by input will be formed. So,
Yeah.
sir, after that, sir, it should be a measurement question. Nah, I
That's what
think.
you're missing. That's what I'm telling. In this G1 output, see, like this, the question is there, right?
Okay. Yes, sir.
G1, G2, G3. Here, this output is given to this. Okay.
Okay, sir.
This output is given to this. All are linked one. All are linked one. Means this is dependent. Means output is dependent on each and every stage over there. So that is the reason why. If the dependency is there, automatically you have to take. What is that? Normal division means subtraction only. That's why in the parallel also I told you. R1, R2 by R1 plus R2. Resultant is depending on combination of these two. R1, R2, R1 plus R2. Dependent combination. That's why error will be minus in the last. Here also same. Suppose if I take V by I, V separate, I separate. I1 plus I2. I1 separate, I2 separate. There is no dependency combination over there. But here, dependency is there. That's why you have to take division means automatically minus sign, like our parallel. Here, this resultant R total depends on R1, R2 combination plus R1, R2. One more combination means dependency is there. But in this, directly one parameter, other parameter. There is no
Okay,
one
sir.
to one
Yes,
dependence.
yes. Sir, just then we can make general statement that if there is any dependency term in numerator and denominator, we can just subtract numerator and denominator
Yes,
error.
very good. Yes.
Okay, and suppose, sir, they give the equation like I1 into I2 divided by I1 plus I2. Suppose a general equation they give and they just give the error. In that section, sir, we have to do subtraction. Na?
Based on the given question, is it from the parallel circuit given? Is it normal circuit is given?
No, sir. They just given that y is equal to I1 into I2 divided by I1 plus I2. They just give this equation and they give I1 having something error, I2 having something error, and they just said that in this y, how much will be error, final error. Then in that case, what should we do, sir?
Negative only, because it is dependency only.
Dependent. Okay. And sir, one another doubt in 2015 question. Sir, in that question, I got the 12.2 kV. I actually WhatsApp you, sir, also. In that, sir, I'm getting a 12.2 kV answer, but actually the answer is 12.22 kV. So, sir, why actually this difference in that
How do you know
answer?
actual answer? Where did you see that actual answer?
Sir, in a book, sir,
Uh,
is yes, previous year question book, PYQ
no.
book.
No, might be their mistake, right? There might be a mistake, right, in that solution.
No, sir. They actually there is means actually I checked in two book also, sir.
No, I
Then
have seen two steps you have given. You only, I think, right? See, my question is, whatever the solution you have seen in that booklet might be wrong.
Okay, sir. Yes.
Are you getting my point?
Okay, sir. Both I have two books. In both, may they having the wrong answer.
Have you seen our AS booklet?
Yes, sir.
In AS booklet, which is there?
Yes, booklet having same answer. Actually, there is no any option in that booklet, so we have to
One second.
like write the answer.
I have that booklet and this.
Just in fifth, I will check.
Tell me, what is in AS booklet? Have you seen?
Just yes, okay. Yes, sir. Actually, in his booklet, they have given different.
Which
Right,
is there?
right. They giving 12.
Huh?
Yes. In fifth question. Yes,
What is
yes.
the answer
Got it,
given?
sir. Actually,
I sent the message
yes,
also.
correct,
12 is
sir.
correct.
12.
I sent
Yes,
the
yes,
message
yes.
also. 12 is correct.
Yes, yes, yes. Got it, sir.
Right.
Yes. Okay. Thank you so much, sir.
Right.
Thank you so much. Yeah.
Okay, then I'm
Yes,
stopping.
sir. Thank you. Thank you. Good
Right.
night, sir.
Good
Good
night.
night.
Good night.